apologize if it went too fast. If I have any questions for anyone in the room, please ask and I will answer. Otherwise, reach out, like I said. So what is Zirkit? Zirkit's a fairly new zero-knowledge rollup. We've been building for a couple of years, but we came out of stealth and started sort of showing off our testnet at DevConnect in Istanbul in November of 2023. And what we wanted to do is take an optimistic rollup infrastructure, that one built by the optimism people who are doing good things, and put in a zero-knowledge proof system because we were sort of sick of waiting 7 days for withdrawals, and everyone just said it should work. Turns out it was a lot of work, but nonetheless, we got here, and it's great. And what that means is we have a VM and a node infrastructure where everything just works on Ethereum. So it should be as simple for everyone in this room to change an endpoint to their favorite tool, whether that's MetaMask or Hardhat or whatever people are using these days to build dApps, and it'll just work. And we've tested this, so I know that this is a true claim, more or less. But it's really cool because you get all this cool stuff that works with Optimism and Ethereum itself out of the box with a zero-knowledge system that reduces the finality time. And we got here through some research. We had a lot of ideas for things on security and just different ways to do things in a rollup. In the zero-knowledge side, for example, there was always ways to optimize things. But what we really wanted to do as a research idea was to figure out how to make Zirkit more secure ecosystem than your average rollup ecosystem. And this is a really hard challenge because zero-knowledge proofs do that in the sort of sequencer ecosystem, the infrastructure for the sequencer. I can't cheat if I'm using a zero-knowledge proof system and I've done my job correctly and there are no bugs and things like this. But that actually doesn't give us a lot of protection for the rest of the users in the space. I mean, certainly it means I can't make up money for myself and then rug pull my users. That's very helpful. But it's kind of a solved problem with the zero-knowledge proof. What we wanted to do instead was bring something that even dApp developers and users of our network would gain even without doing any extra work. So what we want is to prevent hacks everywhere. We can't do that. We don't have total control of the Ethereum network, obviously, so we can't do it everywhere, but we can do it in some places, namely on our rollup. And so what we did was we actually added this idea of sequencer level security, which I'll talk about very quickly in a couple of slides, and I'll tell more about that. But first, let's focus on the first thing about building on it. And like I've already said, anything that works on Ethereum or on the Optimism stack will work out of the box for us. If it doesn't, let us know. It's probably a small configuration issue or a bug, but in principle, everything really works. So your smart contracts are going to work, your wallets are going to work, but do note we're not on the superchain. We're built on the OP stack, but because we've done something different with our sequencer, we're not on the superchain, so it's going to be a slightly different setup, but it should still be very easy. Then we took all the stuff that was good there, and we already talked about how we put ZK circuits in there. As a dApp developer, you don't need to know about that. If you're interested in taking a look at our circuits or building stuff with the type of circuits that we were using, we can point you to some places that look kind of similar to what we're doing. There are other open source projects right now that use sort of a lot of the same ideas or were starting points for even our project. And what this means is we have a nice developer experience, or at least I hope so. If it's not, please let me know. This is a hackathon. Part of what we're here is to get some feedback from you. And in terms of the zero-knowledge proof systems, one of the places we could start was the privacy scaling aspiration team ZKEVM, which has been out for a while. I don't actually know if it's being maintained anymore. I heard a rumor that it's not. I haven't followed up. But if you are interested in trying to build your own ZK rollup or seeing how complicated it was to build Zirkit or something like this, take a look at these. They're very good. They're not necessarily as performant as you'd want, or they have different configurations that maybe aren't ideal, but we ended up using them. If you're interested and want to learn more about Halo 2, this is also a very good starting point because this is the proof system that we use. And at the end of the day, we glued these two things together to come up with Zirkit. I've already said this. And the result was something that has really, really good, easy to connect infra that works, as well as a very good, well-developed set of circuits that were customized and optimized to do whatever we want, and enables us to do some of those things that we wanted to do, namely add some security. So I think the next slide is the sequencer level security, which I'll talk about. But also, if you also have very ambitious goals for this hackathon and you want to build a rollup, forking these two repos and trying to get them to talk to each other is non-trivial. It does take some time. So I encourage you to try it, but it's actually, substantial amount of effort. But it is a really cool challenge. But what we really wanted to do is add some security. Okay, I guess the next slide. I'm sorry, I haven't practiced this one as much as I should have. So what you get from all of this is EVM compatibility. I think I've talked about this, so in the interest of time, I'm going to do this. I will point out one note that I didn't talk about. We don't have support for Cancun. So if you're building something that needs transient storage, the testnet for Zircuit unfortunately will not support it at this time. We're working on it, but we got to get things up to date. We just, I think, moved to Shanghai relatively recently, sometime in the early year. So everything up to that VM should work, but anything else might need some things. If you have questions or concerns or want to help us get there, please let me know. And you get better finality. I've already talked about this. So I've alluded to this topic. I'm going to spend some time here because I'm running out of time, and I want to actually get to the hands-on part of this. I didn't actually want to be talking about what we're doing for too long. But the main draw to Zircuit is really this idea of added security and the sequencer level security. So what we do is we have a sequencer that's currently centralized, and we actually have an AI in there that will look at transactions and flag them as malicious or benign. And if they're malicious, they're going to go into quarantine, and if they're benign, they're just going to go. So if you're an honest user, there's no difference to what your transaction does. It's going to go through every time. You're going to transfer your funds, you're going to mint your NFTs, you're going to do whatever you want to do on the blockchain. But if you're a hacker and you're trying to execute something that certainly looks like the old stuff that we've seen, or trying to do something else that is still new, but it's going to wipe out a DeFi protocol, that's actually going to be flagged for quarantine and put into quarantine, which means your dApp won't be wiped out if you're the dApp person who's getting attacked, and if you're the attacker, that transaction is not going to go through. Now, that might be a little controversial, but honestly, we think it's a very pragmatic, practical approach to security, and everyone on the chain gets it for free. So if you build a DeFi dApp, and you come to Zircuit, now you have an extra level of protection against flash loans that you don't have on another level, on a different network, without doing any extra work. And that's really, really key. We do all the lift with the AI to figure out what's a hack and what should be stopped. That does not mean you should deploy code that has a bunch of errors or bugs. Please don't do that. Do your part. Write good engineered smart contracts and DeFi dApps to protect your users. The SLS is a best effort service. It could not catch something, but ideally it does. The point is, though, we get this nice, great thing that gives us more security guarantees, right? So in addition to transactions being well-formed, they also have to be well-intended in some sense. So that's what sequencer level security is, and here's sort of how it works. Basically, we do some stuff in the sequencer. In the interest of time, I'm not going to talk about it. Please hit up our docs. We have some prizes, which I'll talk about near the end. If you want to work on stuff related to SLS and need more details, come find me or my colleagues, and we'll see what we can do about sharing some of this information. So that's Zircuit in a lightning round that probably was too quick. But let's go on to the hands-on part of this. So if you've never used a rollup, this might be interesting, and it might be surprisingly easy. If you have used a rollup, this may not be as interesting, but bear with me as I go through. I'm here with Zircuit, so I'm going to point you to a bunch of tutorials and guides built from Zircuit. Docs.zircuit.com is a great place to connect to our network. It has everything you need to know about connecting wallets or infrastructure or setting up, whatever your frameworks for development is. And we also, have a standard bridge, a canonical bridge, and a standard block explorer. So bridge or explorer.zircuit.com will take you there. Feel free to use them. Please do use them. If you're trying to claim prizes for Zircuit, you do need to have your code verified on explorer.zircuit.com. And then if you need questions and we're not around, or you're remote and you're not here in person, ask us on Discord. We're happy to help. And finally, two other initiatives that aren't directly related to the hackathon, but you might still be helpful, are build.zircuit.com. So it's a place where we reward partnerships with the ecosystem. So if you finish a project and you think it's actually going to be going somewhere and you want to deploy it, come talk to us and deploy on our network and when we go live. And we can sort of hook you up with all the support you need there. And if you're into LRT and LST restaking, we can also offer you points by restaking in stake.zircuit.com. But those are less important. Okay, I feel like I'm talking a lot. I've got 6 minutes left. I got to get through this. The hands-on part, we're going to use the Zircuit testnet. And Zircuit testnet is a testnet, unfortunately. It's not quite live. We're going live very soon, but I don't want to promise any explicit dates, especially as I'm being recorded, and people, always hold me to dates. So you'll need Sepolia ETH, good resources for Sepolia. There's a bunch of faucets. ETHGlobal's got a really good one. It also gives you ETH on Zircuit itself, directly on Zircuit. So you don't need to bridge necessarily if you withdraw on the ETHGlobal faucet, but there's other ones. Also, if you do find me around and you ask nicely, I can probably help you out a little bit. I'm not going to give out tons, but maybe I can do something. Otherwise, once you connect, it's pretty easy, so I'll go through Sepolia very quickly. I'm going to use MetaMask for this example because I think a lot of people are still familiar with that. Maybe I'm just old and it's not popular, but I like it. Basically, to connect to Sepolia, all you want to do is you want to switch this toggle to on so that you can see test networks, and Sepolia should be baked in. Connect to that. Then you can go to the faucet, collect the funds I was talking about. And then to go to Zircuit with those funds, it's very easy. Just go to bridge.zircuit.com. After you add Zircuit testnet to the network, all of this is on the docs. You don't need to worry about the specific numbers or chain ID or anything like this, but it's just this easy. You go into MetaMask, you want to add yet another network. You say add custom network, because I don't think we're in there by default just yet. Add these details and everything just works. And then you go to bridge.zircuit.com. It'll ask you to connect with MetaMask. Just hit next, you'll be fine. And then you just choose what you want to bridge. Right now, I think the support mostly is for ETH, Sepolia ETH. So take, from Sepolia onto Zircuit, put in some number in that field on the bottom left, say I want to bridge it. This modal will pop up and say approve this in your wallet, and then the next slide, you just go to, MetaMask and say approve, and everything is done and everything works. So it's just that easy. Once you have ETH on Sepolia, on Zircuit testnet, you can use it just like anything else. You can send it to other people on Zircuit. You can, take your keys and put it into Hardhat and produce a Foundry or whatever it is you want to do, and you're all set. I was going to say more, but I didn't. So, there's a lot of docs. I'm going to give you some homework instead. The withdrawal is a little bit more complicated. It's not prohibitively complicated. Go try it out. More importantly, go to try to deploy contracts on it. I think that's the more exciting stuff, and build on it and see what you can do with this. And because we're at a hackathon, try to win some prizes. If you're here, we've got a lot of prizes out there. There's ones for best project, best integrations or analytics. They're still fairly new. There's a lot of low-hanging fruit that probably will work. Best DeFi, best gaming, and most creative project. You can see more on the ETHGlobal site for these descriptions. They're pretty open-ended. The best will just be the best, whatever that means. We want quality, we want completeness, good code. And we want some of these requirements, which are a little bit of a mouthful, but essentially a README that says what you did, why you did it, how you did it, that type of thing. And stuff to be deployed on Zircuit. What a surprise. So that's all really good, but what I would really like to emphasize, if you do submit for a prize, the one thing I will really ask you for as a personal favor here is feedback. If it didn't go that well, if it didn't work out, I want to hear, because I don't want my network to not be easy to use or anything like that. So feedback is greatly appreciated. And if you think it did go well, but we could do something even better, please let me know. I think that's really, really valuable feedback. So thank you. I encourage you to build on Zircuit so that when sequence level security is live. I can send it to you or tweet about it or something. Yeah, it's probably not on the docs. The docs should have everything else though. Anyways, build on us so when sequence level security is there, you can use it. Thank you. I'm gonna pull it. Okay.
Okay, are we good to start? Okay, hello. This is kind of a two-part presentation because we don't know the makeup of the audience. So I'm going to poll you guys for kind of what I need to explain and what I don't. And depending on how it goes, I might disappear immediately. So we'll start off. Does everyone here know, like, who here knows how, like, roll-ups work? Kind of. Okay, cool. I will try to start from the beginning but talk super fast, because we are super intense on time. So we have building on Scroll today. We're talking about the intro to Scroll as well as exploring L1S load. We do a lot of internal research. So today's bounties that we'll be doing kind of covers both sides. So I'm going to start off with like the basics, right? Like what are rollups? Well, why do we even have them? Ethereum is fucking slow and expensive, right? Exactly why? We're going to talk about the blockchain trilemma. So basically it's a pick two situation between scalability, security, and decentralization, right? You can't have all three together. So what do we do? I mean, ultimately, at the end of the day, Ethereum's like principles are security and decentralization. So how do we solve that? And so that's where L2s come in. So L2s are basically, what they do is we take the execution off chain, right? So rather than having to do all that expensive compute on Ethereum, we actually do it in a separate network, which is the L2. It's called a rollup because we basically roll up all these other transactions and then post them to Ethereum. What that means here, I specifically specify here, is data availability. So we inherit the security and decentralization of Ethereum because all of that data gets posted back. So I think another thing that I want to clear about a lot that I think people get confused about is if you know Polygon proof of stake is a scaling solution. It is not a layer 2. And it is specifically because they don't post their data back to Ethereum. So that's like an important thing to kind of differentiate. Now we dive into like the different types of rollups. So in kind of the history of rollups, you might have heard of optimistic rollups. So they're kind of the ones who came first. And they differentiate themselves basically on how they prove. So when we post that data back to Ethereum, we want to verify that it's true. We can't just like post random shit, right? So what that looks like is with a fraud proof, we just optimistically assume that it's true. There's like crypto economic incentives that basically make it like so that you don't want it to not be true. But what that means is we have like, I guess, something called the challenge period, right? So we need to set aside time for people to come and say, hey, that looks kind of strange. Let's do a fraud proof and then actually check whether or not this is correct or false, right? So what this means is we have like what we could say like slower finality being like it's time to finalize on the L1. Right? Which also means withdrawal times or so. Withdrawal means pulling from the L1, so getting your funds out, right? So there's like a little bit of liquidity fragmentation. If you've interacted with rollups, you probably actually don't experience that because you're using third-party trusted bridges to basically give the feeling of instant finality. But obviously we know, well, hopefully you know, bridges have been, I think, the major hacking point that we've touched. So anyways, that was the first iteration. What's the next iteration? We talk about ZK proofs, right? So instead of proving, like having a challenge period, let's be proactive about it. Let's mathematically prove this first and then submit the proof of verification first. The other thing that I always like to note here as well is with ZK proofs, people often think privacy. With ZK, we don't use it for privacy, we use it for scaling. And what that means specifically is proofs. ZK proofs have the smallest amount of data that we can post back. What makes a rollup expensive is that data size that we're posting back, as well as like the verification compute time. Anyways, so that's the quick overview. And now we're gonna dive into a little bit about like, okay, wow, there's so many ZK rollups, how do we decide between all of them, right? So if you're not familiar with the different types of ZK EVMs, basically there's 4 different types, ZK EVMs being at a very high level kind of the way you translate code into math in order to make it provable, right? So type 4 is going to be the farthest away from a ZK EVM, or like a pure EVM. So what that looks like is a ZK sync or a StarkNet. What that means for you as a developer, it's high-level language equivalent. It is not bytecode equivalent. So you're going to have to download plugins. It's not going to look exactly the same. We can kind of scroll down to type 2. So that's kind of where scroll sits. We are bytecode equivalent. So what that means is, you know, it compiles down the same. Your precompiles, opcodes are covered. It should feel developer experience-wise exactly the same. So normally you deploy, you're like, oh, my network is Sepolia. You literally just switch the words to say scroll, and it should work, right? And then type 1 is going to be Ethereum equivalence. Basically, the main difference here is like the way state is hashed and stored is a little different. But for the most part, as a developer, type 2 is kind of the seamless experience that you'll get. The trade-offs here are going to be like type 4 because you're the farthest away. It is easier to be faster and cheaper, whereas type 1 is going to be like the hardest to become fast and cheap. But that being said, technology is ever moving, and I think the assertion that a type 4 will always be faster and cheaper is not necessarily true. So anyways, move on. We talk about scroll. How does it fit into the picture? I don't know how much time we have left, so I'm going to talk about this really fast. So like I said, we are EVM compatible. We're type 2. What that means is we leverage the network effects of Ethereum. Oh, we have 5 minutes. Shit, okay. We have 10 minutes. Oh God. We're secured by ZK proofs. I think the other thing that I want to touch about was security, especially when you think about bytecode compatibility. How many of you guys are familiar with the Viper hack? Nobody. Okay, so basically, Viper, right, is a high-level language, right? So you can write smart contracts in Viper. What happened was, I don't remember which protocol, but they lost a bunch of money. And why was it? It wasn't because the code, smart contract code had a bug. The Viper language itself, the compilation had a bug, right? So that's not like something you can really protect yourself from. So when I talk about like bytecode equivalence, I think something I also like to think about when it comes to like a type 2 is because it mimics the behavior of Ethereum, like the EVM, like you have that additional level of security that you wouldn't otherwise, because from a smart contract auditor point of view, the farther you are away, the more kind of layers you have to think about, which could potentially open up more attack vectors. Anyways, so scroll is this. So we talk about, I think someone always asks me like, okay, there's so many roll-ups, what are we thinking about? The spicy answer is tech doesn't matter, ecosystem is the only thing that is there, right? I don't necessarily think that's true. I think it's a marriage of the both, but if we're gonna talk about what Scroll looks like on the ecosystem side, I think we'll talk about grants a little later if you want, but I think we're really focused on like definitely like supporting builders, like a lot of one-on-one interactions. What I say when someone is thinking about like where do I want to build, the things that you should think about for a chain is longevity and legitimacy. So there's a lot of different like technology coming out. Is what you're building on going to last? In Scroll, we have like a really strong name. And so yeah, the other thing is I think we have a really great support for emerging markets. So if any of you guys are from there, please talk to me. I want to figure out how to help build your community. Anyways, growth is insane. Those are big numbers. Anyways, so that was the part 1 to the deploy kind of casual. I think we're gonna dive into, like I said, Scroll's really heavy on the research side. You have a question, we can talk afterwards. Daniel's gonna come up and talk about something really cool called L1S load that you guys could also potentially hack on.
All right, thank you, Emily. I don't have quite Emily's energy, but we'll get into this anyways. Cool, so that's the background on Scroll. I'm gonna talk to you about something that we have only on our DevNet. So we have our Sepolia testnet that you can hack on for the hackathon. For this hackathon, we also have a DevNet that has a special feature called L1S load. Going to be a little bit lower level probably, but we're going to dive in here. The idea is that we want to have a contract, we want L2 contracts to be able to directly read L1 state, okay? That's about it. And we're going to look at like why that's maybe valuable, why that's interesting, how to use it. And it's something we're introducing to try to get all the rollups in the ecosystem to align around, because we need this to be a standard across L2 ecosystems. So why? Well, there's plenty of reasons to read L2 or from L1 into L2. There's a lot of value in the Ethereum storage slots, right? It has the best security and decentralization guarantees. It is a kind of politically common ground but amongst all these L2s. Has a lot of credible neutrality. It's the default for protocols and also like past activity on Ethereum. There's lots of valuable and interesting data there, both on Sepolia and mainnet. And every rollup has a canonical bridge that finalizes its state there. What that means is the state root contains a lot of information that you can extract out of it. And if that's sitting on the L1, you can start reading about other L2s from your L2 by getting that off of the L1. We'll kind of see that a little bit, but I think we'll have to push to have some conversations outside as well. One thing that we've been looking at for this is the key store. The idea here is that your verification logic for your smart contracts can live on the L1, and you're able to reference it from all your smart contracts on the L2. Think, oh, data on L1 is expensive though. We've been kind of like working on a proposal where you read it off the L1, but you can delegate to update it from any of these L2s. Also happy to talk about this at any point. This weekend I'll be around. Why are we doing this? Because direct reading from the keys, from the L1 is like way easier and cheaper for users, and there's a lot less infra work required for app developers, wallet developers, or anything else. There's lots of other ways to like, prove state, including all these paths here, but they're complicated, they're burdensome, and instead, we get to do something like this as smart contract developers. This is a full contract that will read from from the L1. You pass it your contract address, you pass it the storage slots in that contract, and it will return that back to your contract so you can use it for whatever you need to. We'll talk about some of those use cases. So this is the crux of it here. You pass it the precompile address, you make a static call to that, and you pass it the arguments. Cool, I skipped a few slides. One kind of interesting demo that we did last month in Berlin was we worked with the Safe team to where if I have a Safe wallet on the L2, it will read the signers and how many signers are necessary from an L1. So that way, if we have a treasury on L1, it's being managed by some folks. Every time that gets updated, I don't have to go to every L2 and update the list of signers and go ask everyone to go do additional signatures. Like all of this stuff can now become seamless cross-chain. So that's kind of one of the things that this unlocks. But when you start doing cross-chain stuff, it might get complicated. We might be doing Merkle trees. We might be calling ETHGetProof RPC methods. You might have to deal with like Scroll's zk-try and our zk-try verifier. So there are resources that you'll have to dive into if you want to get really complicated with these architectures, but you could also just read a storage slot. You can read the name of a ERC20 token or something else. And I'm happy to like sit down at our booth and kind of walk through some of these resources if the documentation that we've provided doesn't get you there. What does this enable? Well, we can now have trustless cross-chain coordination. This is something that's like not necessarily possible using the other kind of tools and bridges that you're imagining that are accessible to devs. We can start building asynchronous composability. We can do things like the key store. We can have ecosystem agnostic minimal rollups. That's a mouthful, but the idea is that you can devote just a really simple rollup to doing one behavior and then just utilize that from other chains. We can think about bootstrapping new rollups by reading from L1 Oracle data into the L2s. We can think about verifying asset or NFT ownership from a different network because oftentimes people want to keep their NFTs on the L1. And then if you want to get really fancy, you can think about using L2s to do the ZK verifiers and coprocessors for L1 protocols and then bridge the state back and forth. There's lots of design room here when you're thinking about the patterns and architectures for your hack, and we would love to see all sorts of wild and crazy ones. For me, the weirder the better. We have introduced this as an RIP to the ecosystem. We're looking for feedback, so if you're also like on deeper into the research side or just have comments on how it worked, please give us feedback on this in the Fellowship of Ethereum Magicians. And help us iterate on it. For rollups in ecosystems, we really want people to either get behind the RIP or give us reasons why they won't be able to implement it. But for app devs, it's more about testing, ideation feedback, and for hackers here, we have 2 prizes at $2,000 each. And remember, you can just read any state from Sepolia. So if all your hack project is on Sepolia and you find an interesting reason to like pull that into an L2, make it happen. So this QR code will get you to a kind of hacker resource page with information on our prizes. There's a link to both a Telegram bot that has a faucet for the DevNet and for Scroll Sepolia. And there's also a link to what we call a hackathon cheat sheet that should tell you all sorts of different projects that Scroll Sepolia supports. So if you're looking to hack on 3 or 4 sponsors at a time, Scroll Sepolia is a good option for that as well. You wanting to wrap this up, or should I take the rest of these slides? Cool. All right, wrap it up here. So, hag with us, we've got 10K in prizes. I already told you about the L1S load ones, but additionally, we have best project on Scroll. How much was L1S load? 4,000? That means there's a remaining 6,000 for best projects on Scroll. I don't remember, I think we have a winner and 2 runners up, maybe? So, that can be on L1S load or not. We're just looking for creative projects, weird projects, innovative projects, technically wild projects, or just really good applications and use cases for problems that you kind of see in your own life. So we also have a brand new grants program. There's plenty more information here, but we have a deadline on August 7th. So if you're a builder looking for funding, either you're just kind of getting started or you're needing support to get your project to that next level and really get it launched, check this out. We have up to $10,000 on one track and $100,000 on another, and we'd love to have you building with us, building with Scroll. Thank you, and this is a QR code again for the ECC URL. One more thing.
2 minutes. Read the requirements. You have to deploy and verify. Just so you know. This is my hackathon advice for winning any hackathon. Because people don't, and then they get disqualified.
Contract address in the GitHub, verified on the Explorer.
Yeah.
Always a good thing.
It's so easy.
I guess we have 1 minute. Any questions?
A question about ETH equivalence. So do you have a block hash thing on Scroll? Can you repeat the question?
The question is, do we have block hashes on Scroll? Do you mean every single block, is there a block hash that represents the header?
There is a function in Solidity that returns the hash of a block, and I know that on ZK there are sometimes challenges with hashes.
Yes, there are challenges with that, but I can't give you off the top of my head the actual answer to it, so I'm going to show you where to self-service, which is on the developers area of our documentation. You can see that block hash returns, so basically it's not a proper block hash, but it is a value representing the block that is going to be unique to the chain. So, yep. Cool. Thanks everyone for your time. Appreciate it.
Great. All right. Hey everyone, thank you so much for coming to this workshop. Today I'm going to talk about how to build a blind AI application on Nillion. And just to introduce myself quickly, I'm Steph Orpilia. I lead developer relations at Nillion, and I'm also Oceans404 on Twitter, if you want to ask questions there or say hello. So we at Nillion are building humanity's first blind computer. And the first time I heard that, I was like, what does that mean? How could a computer be blind? Computers are just reading numbers. What is that all about? But what we're building is a dual architecture network. So it is a PetNet plus a coordination layer. So what the PetNet is doing is it's combining different privacy enhancing technologies like MPC, garbled circuits, FHE, all types of different cryptographic primitives to do interesting math on and to do blind computation. And then the coordination layer is how we pay for all of the different operations that happen on the PetNet. So whether it's like storing data, retrieving data, or running blind computation, to do any of that, what you do is you pay on the coordination layer, which is a blockchain, and then you send a ZK proof of a receipt to the PetNet. And so once it knows that you've paid, you're able to perform your operation. So that's kind of what the network looks like at a high level. And we have a test net right now and also a local dev net. So when you're building your apps, you can connect to either, but I'll show you the test net today. Let's go back to this idea of blind computation. So blind computation basically just lets functions or programs be performed on secret inputs without ever revealing them or showing those values. So this is really great if you have a type of application that needs security and privacy, especially if it's combining inputs from multiple different parties. So if you've heard of like a ZK proof, that is a powerful primitive for verification or checking against a single value. But something like MPC in blind computation is powerful because you can compare secrets, add secrets, do anything with secrets from multiple parties without revealing or exposing that underlying data. So it is privacy preserving. And just to show you kind of like classic computation versus blind computation, this is a really simple addition function. It's just taking two inputs, so int1 and int2, and it's returning the sum. So there's two inputs and one output, and if you console logged these inputs in the middle of the program, you could see these in plain text. And something like that doesn't matter for an addition function, but if you think of things that have more sensitive data, maybe you don't want that data exposed. So that's where blind computation could be really great. And what a blind computation function looks like is something like this. So there's two secret inputs. You can see I've kind of put blindfolds over the two secret inputs to show that you can't actually see them, and a sum that's returned. And a big difference between blind computation and writing just like traditional programs is that you attach a who and a what to each of the secrets that you're passing into a computation. So you can see that int1 is attached to me, I'm the party providing it. Int2 is attached to my coworker Charlie, he's the party providing int2. And each of these also needs a name so that we can reference what secret the integer corresponds to. So that previous slide was just kind of a simplification of what a program could look like, but this is what it actually looks like. We have a language called Nada. It's based on Python, so if you're familiar with Python, this should look very similar. And I'll just go line by line and explain what's happening here. So on line 1, we're just importing Nada DSL, which is the library that helps the compiler understand what's going on. On line 3, we're creating that function. And then on line 4 and 5, we're defining the parties. Those are the who, to who is providing the secret inputs. So on line 6, you can see for int1, party Steph, which is me, is providing the secret input. And then on line 7, you can see party 2, Charlie, is providing int2. So when this computation happens, it's completely blind, and one of the different parties, which happens to be me, Steph, will receive the output, but I won't have any idea what Charlie's input was, except for that I kind of know because I provided one of the secrets, so this is not the best example because I could just subtract the output from my original input. But you can imagine that as these get more complex, the programs get more complex, you would have no idea what different secrets were passed in. All you would know is the output. So this is an example of just a simple addition program, but we've also got two different libraries that help you do really interesting things with AI. So the first one is Nada AI, and we have different models that are able to be exported. So we've got linear regression, neural networks, and then some more complex ones like time series, span detection, and forecasting, and also classification. So you can do all of these things within your Nada programs, which makes them really powerful and also allows you to run blind inference, which I'll talk about next. We also have a library called Nada NumPy. So this is really similar to just the NumPy Python library that you might already be used to, and it makes it easier to just do matrix operations and any of that more complicated math within Nada. That way you don't have to write all these functions out yourself. You can just use the helpers and have a better developer experience. So what I did for this example is I created an example of linear regression on housing data with blind inference. So we're going to get into this code, but just in case anyone's not in the AI world, inference is when you take a trained model to make predictions on new data. So for this data set, I used some housing data from Kaggle, and what I did was put it into a model, and I trained the model, and then I put the model weights into a secret on Nillion, so that anytime somebody adds new inputs, they can be evaluated against those secret model weights, and it will come up with what it predicts the new price of a home that adheres to the inputs is. So let's check out this code. You can scan the QR code here. I'll give you a second for that. But this is my repo. So again, it's just doing the linear regression, and I'll open up the actual code. Okay. So this is the Nada program for linear regression. So I set it up by importing Nada NumPy and also Nada AI, and then I need the linear model from linear regression. I'm setting the precision, which is just 32. That's just what I figured was the right precision for this model. Then I create the two different parties, so party 0 and party 1. Those are just each of the parties that we'll use in the computation. And so the first party will be the one that's storing the secret weights of the model, and the second party is the party that's providing that new input data to figure out the price of this new home. So this data set happens to have 12 different features. We can just look at the data set really quickly on Kaggle. It's things like square footage of a house, number of bathrooms, number of bedrooms, and that all corresponds to the overall price. And that's what we'll be guessing when we pass in new inputs to run blind inference. So that was the data set with 12 different features that we're interested in. Then we take the linear regression model and tell it how many features, which is 12. Next, we load the model state, and then also the input data to compare against. And then we get the result of the blind inference. So this is just telling us the expected price of the new house based on the data that we pass in. So this program does a lot, but it's actually pretty simple. And the way that we interact with it is either through the JavaScript client for Nillion or the Python client. So I'll show you the Python code first, but we'll eventually plug this into the JavaScript side so that we can create a web app where we can actually run this program against data that we're putting in on the fly. So if I go to my main file, this is where all of the different Nillion code is happening so that it can connect to the network, store the relevant secrets in the programs, and also pay for the different operations. And in this file, I also compared the result that I'm getting from the Nada program to something from the sklearn linear model so that we can make sure that what we're getting from the Nada program is about the same as what we would get from a different model. So we're setting the precision of the model, and then we're referencing the program that we wrote around linear regression that I just showed you. Next, we have to just establish the party names. So party 0 is the one that is passing in the secret weights, and party 1 has the new input data. And then we just do some setup so that each of the different parties has their own user key ID pair, which is just, it's kind of like a private public key for a user. Then we configure payments. So I'm just setting something up with a ledger client, and that's reading from a private key that's been funded. So you can just fund with our faucet, and then your private key will have some nil tokens that it can use to pay for any of the operations that you're doing. So next we store the program. This just stores that linear regression program in the network. And then we store the 2 secrets. So the first secret that we're storing is the model. So this is all of the different model weights that we found when training the data set. So the model weights are stored as a secret in Nillion. We give permissions to anyone that needs to run this program. So we'll give permissions to the front end and a couple other users. We do that by user ID, which is the user public key. So I added a couple different user IDs so that we can do this from the front end as different users. And then last of all, we store the secret. So we store the model as a secret in Nillion. And this is just a test that I did with a house that has these inputs for area, bedrooms, all of these types of things. So when we run this program, let me just zoom in here. I can just do Python 3 main, and this will run through, this will run through my script and evaluate the blind computation to figure out how much a house would cost that has these different criteria. So as the script runs, you'll see that we're getting quotes for operations. That's just estimating how much it will cost. And then once we get the quote, it will automatically pay with the private key. So it submits a payment, it stores the program, and you follow that pattern for any operation you do on Nillion. So you create a quote, which is just saying what you're gonna do on the network, whether that's storing a secret, retrieving a secret, or performing a computation, and then you pay for the operation, and then you can pass the operation to the petnet. So this got the expected result. It looks like this home is about $7.6 million, which seems very expensive, but this is also what the other model got. I think this data set was like fancy homes on the East Coast, so that kind of makes sense, but I probably would not be buying this home. Maybe if ETH goes way up this cycle. Okay, so this is how you create the program and you do all of that. And the next thing I want to show you is how you make this interactive, so how you turn this into a blind app on Nillion. So I've got a starter for you all to check out, and you can find it by going to our docs, so docs.nillion.com. And then you can just go to Developer Quick Start, Build a Blind App. This will take you through all of the steps to actually building a blind app. I showed you creating a Nada project. That's what the linear regression model was. But the actual blind app uses this CRA Nillion, so a Create React App starter repo. And you can use this as your base to build whatever type of project. It has all of the payments already. It has the quoting. So all you really have to do is add your business logic. So this is what the CRA Nillion app looks like. First, I have an operations page, so you can just generate a user key and connect with the user key, and then you can perform any different types of operations. This doesn't actually have to do with the housing example, but it's just to show you that you can store secrets, retrieve secrets, store programs, all of the different operations against the testnet. But if we want to run blind inference to figure out how much the house would cost, we could use this page. So this is just another page I've spun up with React, and it's connected to the specific program ID for linear regression, and it also knows about the secret that's already been stored, and that secret is the weighted model. So I'm gonna generate a user key and connect, and now I'm gonna set some different input features for a house, and the model will tell me how much it is without actually having to see those weights. So the weights stay completely private and hidden, but we're able to run inference. So let's give it a 2,000 square foot area, 3 bedrooms, 3 bathrooms, maybe 2 stories. Nope, 2 stories. We'll say it's not on a main road, there's no guest room. We'll just say no to the rest of these, maybe 1 parking spot. So I submitted the input feature set, and now I can run blind computation on the program. So let's get the quote. This is just an estimation of how much this operation will cost on the network. It looks like it'll cost 28 UNO. So then I can pay and compute. And I should see the result of the blind computation. Come on, Wi-Fi. Let's see. Okay, so we'll just give this a minute to load. Oh, here we go. So it's saying that this house is like 4.6 million, which is also a lot. But again, this was a pretty expensive data set, so I think that's why. But this is an example of how you can plug your programs into an app and a front end really easily with our JavaScript client. So whether you're writing code in Python or JavaScript, you'll be able to create web apps if you use the CRA Nillion starter repo. So that's the linear regression model example. And I just wanted to talk quickly about our prizes. So we have 5,000 USDC in prizes. So we have 3,000 for building a blind AI project on Nillion. We have 1,000 for building a blind app, which doesn't need to use AI. And then we have 1,000 for the best tool or blockchain integration. And we also came up with a nice big list of ideas for you all. So this has ideas for each of those prize categories of the different types of things you can build. And this is linked in our prizes, so just look for Nillion ideas inside of the prize links. But there's tons of different things you can build with AI, with the different models that we've exposed in Nada AI. So you could do something with housing data, like what I did. You could do something with health or medical imaging. You could predict temperature, anything like that. For blind app ideas, one thing that I've been thinking about a lot is creating like a meeting calculator, like to calculate the cost of a meeting. If you had each of your coworkers secretly put in their salary and then you calculated how much the meeting cost based on the number of meeting minutes, I think that would be fun. You could also do things with secure voting, blind auctions, and we have examples of both of those. You can do a multiplayer game, anything that requires secrets to be stored and computed on. So anything where privacy and secret storage is important for computation. As for developer tool ideas and blockchain and app integration ideas, basically if you combine us with any other sponsor, you'd be eligible for this prize. And it's especially good if you're deploying to a bunch of the L2s. You could maybe store your store IDs on chain so that those stay on chain forever without exposing the secrets. You could create a Farcaster frame, anything like that. You could build a bridge. We're looking for anything creative, and especially things that we haven't thought of on this list. We're excited to see what you build. I think that's everything from me, and I saw that it's time, but does anyone have any questions about prizes or anything? Otherwise, we'll be at our Nillion booth, so we're happy to help all weekend long.
Okay, so we're ready to go. Hi everyone, thank you so much for being here. I'm Guillermo. I'm part of the developer relations at NEAR. And I'm here today to talk about NEAR, the one chain to abstract them all. So today's goal basically is that I want all of you to know that we have two bounties, which add up to $10,000. One is focused on chain abstraction, and the other one is focused on AI. And I want you to go out of this talk, with a good idea of like what is the NEAR tech stack, and also have a clear understanding on how to continue after you see everything I'm going to show. What is our documentation? How you can reach us to us for support, and also to give you some ideas for the hackathon in case you want to build something but you don't know exactly what. I will encourage you all to actually scan the QR codes that you're going to be seeing across the presentation, or at least to take pictures of them, because this is going to be like a lot of information to take in. You will not see me coding as much as you're going to be seeing me explaining concepts that are like important to know in NEAR. So maybe we can start with like, why even using NEAR, right? Like why do we even care about it? And there are a couple of reasons, right? Like we're an L1 that is very fast and scalable. We have 1 second block generation time, and we're sharded by design. Our transactions are in average very cheap. We're talking about like less than a cent. And we are like a certified carbon neutral chain. But besides that, which, like eventually I guess that we all gonna reach that state, I think that an interesting thing about NEAR is that it's very user and dev friendly, because it comes with name accounts. It has a very unique account access key system. It has built-in account abstraction, and it also has the ability to control up to some extent accounts on other chains. So let's start with the first one of the topic of our bounties, which is chain abstraction. And to talk about chain abstraction, we're going to start with our account model. In NEAR, we have two types of accounts: implicit accounts and name accounts. Name accounts are, implicit accounts are the ones that you might have been seeing like absolutely everywhere, which is like just a bunch of characters. So your account is going to be FB09, and which doesn't tell you much. But we also have name accounts, which are like, as the name suggests, accounts that you can just refer to them by their name, like NEAR, Gile.near, app and Gile.near. So the nice thing about this is that they're very easy to remember, and they're also very useful to organize your accounts. For example, if you have an application, you can start releasing like the version 1, the version 2, the version 3, and also use some other of the accounts to put, for example, your DAO or your fund, or like anything else that is related to your account. So it's very simple to keep organized. But also something that is very interesting is that all the accounts are already a smart contract. Like they all can have a smart contract, and they all are at the end of the day a smart contract. If you're interested to learn more about this, I recommend you to scan the QR code, which will take you to our documentation for this. And the second important thing about like NEAR accounts is that they have a very interesting access key model, in which you might be used to accounts having like one key, but in NEAR accounts can not only have multiple access keys, but we also have two types of access keys, which are full access keys, and the other one which are like limited access keys. Now, full access keys are like the ones that you are aware, like, or the ones that you are used to in absolutely every ecosystem, which, like they have full control over the account. They're gonna allow you to transfer all the funds, call contracts, create accounts, add and remove keys, because again, you can have multiple keys. And this is the classic, keep them safe, because if something bad happens to them, like that, it's bad. It's really bad for you. But something interesting is that, since you can have multiple keys, you can also just swap them. Like if you think that one of your keys got compromised, you can just delete it and add another one. And then comes what is very interesting, and the reason why I'm spending time to talk about this is the limited access keys, which are a special type of key that can only sign transactions that are calling a specific smart contract. They cannot spend funds, they cannot create accounts, they cannot add or remove keys, they cannot delete your account, nothing. They just allow you to call specific methods on a specific smart contract. And these type of keys are meant to be shared. And what I mean with meant to be shared, I don't know if you have seen this tweet some time ago. I found it hilarious about like the future of Web3 gaming, where like every time you shoot, you have to sign a transaction. And for me, this was like very, very fun because actually, the whole idea of the limited access keys is that you can share them with some application, and then the application can sign a transaction for you. So for example, like if you want your game to, just be shooting and you want to save each one of these shots into the chain, I don't know why, but you might want to do it, then, you can just give the application unlimited access to your account and say like, okay, you can call the function save shot into this smart contract, and that's it. Like that's the only thing that the application will be able to do for you, and it will highly improve your user experience because then you will not have to ask people to sign. Of course, this is an exaggeration, but it might happen that you just want to store like we have a guestbook example, right? Like you just want to store like a little message, and you don't need to sign a transaction. The guestbook can automatically do this for you. And the important thing about like not only improving user experience is that limited access keys allow to call methods on a contract, but contracts can do everything that an account can. So what if you create a method in a smart contract that transfer an NFT or a fungible token? Now I can give this access key to any of you, and you can call that method and transfer an NFT to your account. And now suddenly you have a link drop, or what we call a link drop. You can see more information about it in the QR code. Or for example, what if I create a method that when you call it, it creates a new account for you? Now I can give you access to my account, so you can call that method and create an account for yourself. And this is very, very, very interesting, right? Because suddenly I am giving you, just by sharing a little piece of my account, I'm giving you the opportunity to gather assets, to create accounts, to call other methods in a specific place that I want you to. And that's why like access keys are so important. Now the next part of chain abstraction is what we call meta transactions. I think that this is already like a term that has been taken by everyone, which is a built-in system to write transactions and delegate them so someone else covers your fees. So imagine that Anna.near wants to create a transaction, right? Like they want to execute something, but they have literally no funds. So what do? They create a transaction, they wrap it into a delegate action message. This is like, something like this specific implementation. You can go into the documentation and see what I'm talking about. But the whole idea is that Anna will create a message that then Anna can sign and send it to a relayer, which is just like a server that is off-chain. And now the relayer attaches some tokens to this transaction and send it to the network. And what will happen is that the network will take it and execute it as if it was Anna's transaction. So this is a built-in system. There's nothing like weird that you have to invent. We just have the relayer. You create the transaction and you say, okay, please someone pay for it, and the relayer will send it to the network and cover it. But the important thing again is Anna, or the transaction, will execute as Anna. It's not that the relayer is going to be executing the transaction. The relayer is just putting the money. And then everything else is of Anna. So this is very useful for example, like if your user has literally no funds, well, now you can enable them to use transactions on Near by just implementing a relayer and meta transactions. Now, so far, I have only spoken about things that are possible on Near. And the next thing that I want to talk about chain abstraction is the concept of chain signatures, which you might have heard. The whole idea of chain signatures is to be able to reach into other chains. This is an Ethereum conference, so let's focus on EVM, but you can also use Bitcoin and other chains. So behind the chain signatures, the main concept that you have to understand is the one of the MPC service, like a multi-party computation service, which what it does is just a decentralized network of computers that can translate a Near account into multiple foreign accounts, like EVM, so Ethereum accounts, Bitcoin, Doge, etc. And this service is out there, listening for signature requests, and when it sees one, it signs them and returns them on chain. So here you can see like we have our MPC service that is listening, and basically we have Anna that now wants to sign a transaction on Ethereum. So Anna asks the MPC service, which accounts do I own, and then asks to sign a transaction by executing an on-chain action, which is just calling the MPC contract in Near. The MPC service, which is outside, is listening to it, captures it, and returns the signature. In between, the MPC contract is just waiting there and then returning the signature to Anna, who can now relay it. So I have a little video showing this. You can find example. Now I will tell you where you can find this example. But basically, you can see that there. I'm just logging in with a Near account. Now I'm changing which account I want to control. I was controlling the test account. Now I'm controlling the Ethereum account. I'm going to fund it using here a MetaMask. So if you give it a second, then the money is going to arrive. If I move here, you will be able to see that we went from 0 Ethereum to 0.05. And now what is going to happen is that I'm just going to be sending a request, so like executing a transaction on Near, where I ask the MPC service to sign for it. It will return it to me, and then I just relay it to the network. And that's it. And this example, you can find it if you go through this QR code. For those of you that are going to be working on chain abstraction, I recommend you strongly to look at that example, because basically it's going to have most of the information and most of the code that you're going to be needing at the end. So I would just give you like 10 seconds more in case anyone wants to take it. I see you're reaching to your phone, so I'm going to be just like mindful of that. You still have time. So what is going to happen is that you're going to be taken to our GitHub, and in that GitHub you will see like the Near multi-chain example, and it will also like within the GitHub you will see a link to our documentation. So yeah, if you're going to be hacking on chain abstraction, very much recommended that you look at this. Now, I'm just going to repeat how it works because this is going to be very useful for like when you're hacking. So Near accounts can control accounts on other chains by you first ask the MPC, okay, I am Gile.Near, which accounts can I control? And it will tell you. And then you say, okay, perfect. Can you create a payload? For example, like by me, like that Ethereum account making a transaction to another, like sending me Ethereum to another account. Then you're gonna make a call on chain. This is just like a normal function call on a Near smart contract. And then you're gonna wait. Meanwhile, what is gonna be happening is that the contract is gonna be in the same time that you are waiting, the smart contract is gonna be waiting because smart contracts in Near can wait. And it's just gonna be waiting until the MPC contract the MPC service answers. And once the answer is there, that's it. Like you will get your signed transaction, which you can relay. Now, so you might tell me, okay, yeah, that's interesting. Like, you sign a transaction. So what's so amazing about that, right? Like, so the important thing is like two things here. Like, the first one is that thanks to the MPC, you don't need to care about like the Ethereum keys because the MPC is gonna be taking care of it. It's not that the MPC, since it's like a distributed network of computers, it's not gonna be able to like take hold of your accounts. It's just gonna be there, like helping you to sign transactions for them. So you know that you don't have to remember the seeds of all of that. If you have like an Ethereum account, that's it. If you have an Ether account, that's it. Now you control multiple Ethereum accounts. And the second one is that the request was made on chain. So it's not only that any Near account can make the request, it's that smart contracts can also make the request, right? Like because smart contracts are also Near accounts. So suddenly smart contracts can request foreign payloads to be signed, which means like now smart contract can ask to get a transaction signed for Doge, Ethereum, Bitcoin. And when you combine all of these things, like the account model with the meta transactions and with the chain, when the chain signatures, what happens is that you have a world of possibilities that you can build, right? Like you could have a DAO Near where people just propose, like different actions to be executed on Ethereum, and it's very cheap to vote and like to make proposals and vote. And you can even, like thanks to link drops, you can drop accounts to the people that you want to be voting here. You could have a smart contract that triggers transactions in Dodge. Like suddenly something happens on Near account, and now you are making a transaction in Dodge. You could link foreign accounts to NFTs on Near, and now you can sell those NFTs, and suddenly you are selling accounts in a foreign chain. Or you could create drops, which drop assets on a foreign chain, right? Like you just control an account that has an NFT. Now you can drop that account on Near, and it has control of an NFT outside of Near. So truly a world of possibilities. Now, that was for the first bounty. The second bounty is about Near plus AI. And what I want to be understood, based on like all the questions that I got so far, is that when we talk about Near plus AI, we talk about Near powered by AI or AI powered by Near. So, think of like the combination of these two things. Think of autonomous agents that can now transact on a blockchain. Or think about smart contracts that can take decisions based on AI models. In the same way that they were waiting for an MPC signature, now maybe they're waiting for like a LLM model to take a decision for them. So this is not necessarily about like infrastructure or like running AI inside of Near, or like, this is not about like necessarily about like GPU power or computational power. It's more about like, we want you to think what good can you bring into Near with AI, or what good can you bring into AI with Near, and all that you saw about like link drops and the account model and chain signatures. So for example, like ideas are fungible tokens as a way to pay for computational time on, on the computational time of course of like an AI model, right? Like, or smart contracts can shield computation and wait for external input. So maybe, like your smart contract makes a decision about like buying some asset or selling it, or like, just make a decision on chain based on what an external model is telling them. Or maybe, it's about AI to help people navigate Web3 problems, like, create fungible tokens, swap tokens using like natural language. So I have added here 2 QR codes. One is about like a small example that one of our engineers created about using ChatGPT through a smart contract. Is quite fun. And you also can see an AI showcase that happened yesterday, where different AI companies showcased what they are building on Near. So let's talk a little bit about logistics now. You can find everything that I have talked about in near/docs.io. And we have a Telegram channel where you can find support from us. And this is the QR code that I put at the beginning, which will take you to the bounties, the documentation, information where to find us, and I will make sure to add the hackathon ideas in there. We also have a booth, so please feel free to come and say hi. We are both like marketing and technical people there. Particularly, I'm technical, someone else is there for support. If you have questions about like how this works, or like how code works, or like you're coding and something is not working, just please come and ask for help. We are here for that. Thank you so much. We have 1 minute if anyone has a burning question.
should we? Okay, I'm gonna yell out one last time if anyone wants to join. Dynamic workshop is starting. Workshop number 1. It's cool. It's cool. That's Did that help? Okay. Excellent. So we'll start, and then hi everyone. I'm Itai. I'm one of the co-founders of Dynamic. What we'll do is two things. Oh, I need to speak to the microphone. Right? Okay. We'll do two things. We will first see a quick demo of Dynamic and how it works, and then after that, we will kind of run through how to build your own thing within with scaffolding ETH, which is a really, really cool thing with Dynamic together, and kind of run through that. So those are kind of 2 steps. I'll run through the demo very quickly, and then I'll hand it over to Matt to actually run through the rest. But the way to think about Dynamic is everything that happens after you click login on a website. So Dynamic, as the name suggests, is very dynamic. It can be kind of a more Web3 first type experience, right? It can actually be a multi-chain, so if you're building on Bitcoin or Solana or EVM, it can actually work that way, or it can be a very Web 2 first experience, so not talking about wallets at all, just social login, email login, and everything around that with wallet creation in the background. Now it's very customizable, so you can make it feel exactly like the rest of the product. You can kind of do it as an embedded thing, you can do it as a pop-up. It's, as the name suggests, it's very, very, very dynamic, right? It can feel exactly like the rest of your product. You don't have to change anything. You can change colors, themes, copy, everything. You can change kind of order of things. So you can say, hey, social login first. Let's merge these. Let's split them. Remove the continue button. Do this fully headless. Whatever your heart desires, you can actually do. Now, the cool thing is with Dynamic, you really kind of, if you don't have a wallet, if the user doesn't have a wallet, and you log in, it's within a single click, it generates a wallet. So that's pretty much it. That was the entire kind of experience, and you got a non-custodial wallet. The end user can export that wallet at any point, but then where it gets really cool is you can start adding things to the profile that was created. So in this case, I added a couple couple third-party wallets. I can link additional wallets across chains. I can kind of, do things and link kind of different MetaMask wallets. So I can kind of, let's unlink this one as an example and add a different MetaMask wallet. So I can add a MetaMask wallet, pop it up, and link it to the same account. So you can start building these really sophisticated experiences for user management. You can also link additional social login methods, right? So this user, for instance, that has multiple login methods, has this really cool kind of structure to the user information of a bunch of verified credentials for that user. So all the wallets that were connected, all the emails that were connected in a single spot. Now, Dynamic takes it a step further, and you have this full user dashboard where you can start doing fancy stuff. So you can essentially, for instance, say, look, if someone logs in with a wallet, let me ask them for an email address, or let me ask them for additional custom fields as part of their onboarding, or create access lists. So you can say, only folks that log into my site with this specific email or this specific Farcaster ID can actually access or kind of get a scope access to that site. So for instance, let's log out and kind of try to log in with the wallet, and if that wallet has access, then Dynamic kind of turns from just an authentication tool into kind of a full onboarding platform. So in this case, I can capture someone's email or social login or anything like that as part of the flow. So it's not just authentication, but it's onboarding and authorization as well. Now, Dynamic is kind of really, again, as the name suggests, dynamic. So you can see it in action in different places. So on Magic Eden, for instance, Magic Eden is fully powered by Dynamic. So if you log into Magic Eden, that all uses Dynamic, and what you can see they've done is they let you now link your Solana wallet, your Bitcoin wallet, your EVM wallet into a single spot. You can kind of link additional wallets very quickly, and here, this is, as you can see, it looks like Dynamic. This is actually Dynamic, and so you can mix and match between a headless version of the product or kind of a more detailed version. A good example, Bracket Game, which is a social-fi type game, uses Dynamic, but just with email. Or Eurocaster uses Dynamic with kind of Farcaster login, right? So you can actually build different experiences very quickly. So if Berachain is an example, all core Berachain apps use Dynamic. So there are different kind of versions of how you can implement this, and it's all with toggles on the dashboard. So it's very, very easy to get started. And with that, I'll probably hand it over to Matt to actually go through how to build something very quickly. Go for it, Matt.
All right. Can we see? Wait, can we not see?
There we go.
There we go. Okay.
Hit allow.
Okay. This talk was not titled this, but I am going to try and give you some superpowers, because we were looking last week at what took people the longest to get going with their project and realized it's not actually integrating dynamic, it's not onboarding, it's the glue to put everything together. If you try to build in your account abstraction layer, your chain abstraction layer, connecting to all of the wallets to actually verify and sign for those transactions, it's not so easy. And we don't want you to have to spend time building the basics. We want you just to build the project. So what we did on top is build something called the Hackathon Starter Kit version of Scaffold ETH. And this is a community project to help you get going. We chose only partners of ETHGlobal because we're here for bounties, let's be honest. We're also here to build something super cool, but it involves getting bounties along the way. So all of these are partners of ETHGlobal. All of them have bounties, and it allows you to integrate them super, super quickly. So I'm just going to give you a brief overview of how to set it up. You can then copy and paste the code snippets that you need to do certain things into your own project, or you can use this one. So to be honest, I think quite lucky if you're here to see it in action, because again, the title of the talk is not this. I'm sure it will be shared more broadly a bit later, but let's give it a go. The easiest thing you can do to get started is npx create dynamic app. You can also clone the repository. I can give you a QR code, but if you do this, it's one line. You can choose Scaffold ETH Hacker Edition. Give it, oh God, I hope. How many numbers do I need to go for? Let's try 15. How many times have I installed this? You can take a guess. And it's done. It cloned the repository. It will remove the remote URL so you don't end up pushing to the original with your hackathon project. And that's it. You can now follow all of the documentation from the README, which is exactly the same as Scaffold ETH, which, by the way, he's staying very quiet, but there is Austin in the back who helped build Scaffold ETH. So if it's working well, cool, talk to me, and if it's not, he's there. No worries. So all you need to do is yarn. We can do that here, but I won't, because we all know how long that'll take. You can run yarn, and then you can run two other commands. Yarn chain will start a local network, and yarn start will start your front end. And once you have it up and running, you'll see something like this. So I'm just going to give you a tour of what you get straight out of the box. It's all of this stuff. Like I say, it's the glue. Okay, so the first thing is that dynamic is there by default. It has a default environment ID, so you can see this set up. You can also add your own environment ID and customize it. So let's say we want to log in with MetaMask. Let's do it over here. We are already logged in and connected to base Sepolia. Now, we all know there are a lot of EVM networks here, and they're all amazing. So I tried to add one and then felt like, crap, they're all amazing, so I added them all. Every single EVM network that's here, which has a bounty, indeed we all do, is present. All you have to do to start testing is click connect, and in the code you can now start signing messages, signing transactions. You can flip over, and I'm going to introduce you to the code now. Here in packages in Next.js, you'll see a bunch of things like components and lib. So you'll see in dynamic, this is how you can send a transaction. You'll see that this is how you can sign a message. Our docs also have this, but it's good to know because it ties up with sign hello world and send some ETH to yourself. You notice that we also had a local network running. So if you're deploying contracts and testing, you will be using that hard hat network most likely. So all you have to do is switch to it, and it works out of the box. You can also not just sign up with a wallet, you could sign up with email and get an embedded wallet, so people don't have to worry about Web3, exactly the same flow. Beyond that, there are a few amazing technologies out there like Polygon, Arbitrum, and they have things like Orbit. Orbit means you can deploy your own L2 or an app chain or any kind of roll-up you want, which is incredible. If you're going for something quite deep, really cool, it actually takes only about 15 minutes to set up one of these chains. I tried it with Orbit. I'll show you over here. This is it running. You don't need to worry about what it's actually saying, but we have a local app chain running. It's a roll-up. Why am I showing you this? Because should you want to enable your own network, if you're running your own chain, here in the Networks tab, you can see the format, These are very easy to find things. You can find them for any network on Chainlist. I'm going to uncomment this one. Let's see if we don't need to reload. We don't. We're going to connect to our own local running chain, and off we go. Let's sign a message. Let's send some ETH to ourselves. I put this warning in just to show you how you can do different UX patterns. You can see it in the code. We will sign and send. And just like that, it's done. If we go to the Block Explorer, which comes with this local chain, this runs on BlockScout. Again, another provider of ETHGlobal. If you go to the blockchain, you go to transactions, you can inspect your coin transfer. So this is all the glue which ties it together. All of the code is in here. You see in the BlockScout lib, a few lines, copy it over, you can start querying your own transactions. Even more interestingly, if you go to the Smart Wallet tab, this is new for this version of Scaffold ETH. Safe, one of the amazing providers out there, I'm a huge fan, allows you to deploy an AA layer, so we'll do it on base Sepolia. All you need to do is click this button and you have a safe account. If you want to add the same in your code, it's over in, I think, app, safe, page, not refresh, not transfer. We have copy to clipboard, and up here, there is deploying a safe wallet. So you can grab that code, check it out, and not have to worry about any of the setup. Once you've done that, you might want to do a cross-chain transfer. Chainlink, who's also out there and is amazing. Done. I think what I'm trying to say is we're all amazing. That's pretty much the point of this talk. But no, I'm just trying to be fair because it's hard to leave out every different kind of technology. So let's see, do we have any balance? Why don't we fund it from the Circle faucet? This is something you can build into your app if you're building on something and you want to let people get stuff very quickly. Let's copy our USDC address, put it in, and what we need to do is move to base Sepolia. Token sent. Let's give this a go. You can now control this flow as you want. We've just kept it plain and simple, so there are multiple approvals on your safe. You could batch up the transactions, you could do it in any way you want. You can have passkey MFA, you can have one-time code MFA to your email, or you can have no MFA at all and just, it's probably unfair to call it silent sign, right? But you can just sign without any process in the back end. Depends on what you're going for. If it's a consumer app, you might want to bundle and just allow the transactions through. It's a big trust assumption, so take that as you will. Passkeys are always there for you. We now have a transaction initiated successfully, as far as I can see, and here we can query it on BlockScout. So that's using the API calls in there. Amazing. So was there anything else that we wanted to show? I can leave a few minutes for questions at the end. As far as dynamic goes, Itai showed you it active on a few sites, but there are many different ways you could implement it. You can do it like Web3 native, completely Web2. I think Doodles is a reasonable example of that. You can do it through Telegram. You can do it through Farcaster. There's a full Farcaster guide section. So in any way you want, you should just be able to pick up the SDK and embed it, pretty much as we've done here. There's also the React Native SDK, if you want to use that for mobile. And you can always browse through the documentation to find anything else. So with that said, the idea behind it is I'm going to show you our prizes. We have here, we're not in London, although that was a really fun time. Here we go. So we tried to tie it in and help you build creative, interesting stuff. The first is for cross-chain. The second is to abstract away crypto, just improve life for people in general, but without them knowing they're using crypto. It's to get around the fact that there's a, literal on-ramp in their minds to, oh no, this is crypto. Then SocialFi, which can fall under quite a broad bracket, but as long as you have a financial incentive to run a social experience or experiment, you're in. Really cool. And then the best integration, so whatever you combine different technologies into to do something novel will qualify. This is because I really want to have fun. Thank you, Itai, for suggesting it. But often, we get too far into the weeds, like the technical stuff and this, but often people just want to have fun. Ideally in Web 2. right? We all know that we love using crypto for fun, like Farcaster and stuff. But if we can use it to have fun for people who know nothing about it, that would be absolutely incredible. Okay, I think I'm on time, in fact, under time. Last thing, we use Pimlico as the paymaster. All the transactions are sponsored with gas. Because it's on a test net, you don't need to create a policy or anything. Just sign up for Pimlico, get an API key, plug it in, and you're good to go. It's all sponsored. If you want to go to mainnet, then you will need your own policy, but you can do that on the Pimlico website. If you want support, Discord, dynamic channel, or ask any of the partners, because most of them know about this. What I'm going to try and do next is deploy a chain on Polygon CDK and plug this in here. But yeah, if you have any questions, we've got the booth over there, and we'll be around all weekend. Easy? Thank you. Sorry. Hey, question. Hello.
You showed at the beginning that you can let the user sign up with email.
Right.
The embedded wallet, but you could also get some other information like first name, but you can make custom fields.
Yes,
So we could have, like, if we wanted to keep track of someone's EA quota for a gas meter.
Nice. Yes.
And can you show where we do that?
Yeah.
Where's it stored? Do you have a local database? Or?
Yeah, so it's stored on Dynamics, kind of on AWS.
Yeah.
Essentially, for custom fields, here
Can I do this?
I'll grab this for a second.
Oh yeah. Hold on.
Essentially, on custom fields, for any custom field, you can do it API based. So in our docs, just search custom information capture, and there's like a kit that shows you how you create kind of a custom field, input type, whether you want any regex type validation.
And you would link that to that wallet address.
Correct, that's right, to that user account. Yes, that's
Yeah.
exactly right. You could put multiple, you can have them show up during onboarding or show up later on, so you have that full,
Okay.
full
So
functionality.
here's the default fields, which you can just turn on. You can either skip them during onboarding or not. And then with custom information capture, you can enable whatever fields you want. It's up to you when you ask for them, by the way. You can ask up front, or you can ask like gradually when you're giving value.
But that would basically save us from having to create our own database.
Indeed,
That's
yeah.
exactly right.
To link that wallet to their EN code.
That's exactly right. More than that, there's so everything user management you can do through Dynamic. So there's a metadata field. So if you want to store information and you don't want to surface it to the user, you can also use that. So if you want to store additional information on the user object, you can do that too.
Okay.
Not just for information capture purposes.
In the last moment, just on that point, as well as linking information, you can obviously, if you have an embedded wallet, you can link an EOA. And if you're on a single EOA, you want to, for example, add your Coinbase as well, you can do that. And because it's fully compatible with Smart Wallet, you can just add that in as well using passkeys. So yeah, multiple information, but also multi-wallet linking as well, which is quite cool.
And
Link.
one more cool, so two other important things. If you're building in consumer crypto and you want, after you create your wallet, there's a concept of transaction MFA. You need an approval or passkey for transacting. If you want to remove that requirement, come to our booth.
Oh yeah.
And add you to a feature flag.
There you go.
Remove that. So essentially, as soon as the user logs in, they can just click and transact with no additional pop-ups. Just come to our booth. We'll add you to that feature flag, and you'll be on your merry way. Just create an account, app.dynamic.xyz, come with the environment ID, and we'll add you to that feature flag. We're around all weekend, so if you want to send stuff our way, come our way. We're here. Awesome. Thank you guys.
Okay. Hi, everyone. My name is Blessing, and I'm the Developer Relations Manager for EMEA region at Circle. Today, we're going to be talking about building with Circle's developer platform. So essentially, what I'll be going over what the Circle developer platform is, what you can use it to build, and how that sort of ties into the bounty and what we expect from hackers today, for the entire weekend, what you can come up with, and also how that ties into how you can win all the bounties that we've listed on the ETHGlobal Browsers page. So starting off, this is essentially what to think about when I talk about the Circle developer platform, and it sort of offers the cohesive technology stack that you need to build on Circle, right? So if you start from the base, we've got the blockchain networks, and you can see pretty much all the blockchain that USDC is supported on. And on top of that, we've got the stablecoin protocol, which includes, of course, USDC and ERC, and then cross-chain transfer protocol, which is CCTP. I'm pretty sure everyone is familiar with CCTP. And CCTP lets you move USDC securely between blockchains. And also we've got the Bridge USDC standard. And sitting on top of that is the Web3 services. And Web3 services allows you to use 3 product offerings that we've got at Circle. We've got the programmable wallet, we've got gas station, and we've got smart contract platform. Programmable wallet lets you embed secure wallets into your application, be it mobile app or web application, and you can also embed a gas station sponsoring gas fees for your users, so they don't have to go out of your application, be it mobile or web application, to source for native gas, and they can just do that right in the application. And programmable wallet is really special and unique in the sense that you can interact with smart contracts. We've got an endpoint that lets you create transaction, and it's super easy to use with just an API call. You're ready to go on your way. So on top of all these constructs should be your application or your business. So if you are building something in this hackathon, just think through, like, how can I build my application on top of everything that we've got here as a technology stack to solve the use cases that I'm going to walk through in a bit. So let me just go to the next slide. We'll just go to the price pool information, and I'm going to walk through everything. So on the ETHGlobal website, you can easily see everything, and we've categorized them easily on how you can win for each price category. So I'll start with the first one. The first one is cross-border payment, and you've got 2,000 USDC for this price pool, and it's the first one. So what we're looking out for from this price pool is we're looking for an application that it could be a mobile or web application. It could also be an integration, or it could also be like a protocol integration that uses blockchain for cost-effective international money transfers, and you also save costs while you move funds from one country to another, giving it that cross-border payment flair. And we've listed a ton of examples because we know that developers, you've got like really short period of time during this hackathon. So we want to give you examples that you can easily get started with to help you think through what we're looking out for and help you understand how to win for this hackathon. So we've got payroll platforms, and that essentially means like global salary disbursement, where you can use the blockchain to distribute salaries for workers in another country, and they can easily get paid working for another country. So we've got international remittances, peer-to-peer payments, and essentially one flair that we're adding to this hackathon is we're also looking out for innovative applications that add AI into the integration. We all know that AI is kind of gaining traction now. We just want to explore how you can use AI in blockchain to build really, really cool use cases. And we saw that from the previous hackathon in ETH London, where a developer actually used large language model with the blockchain, paying with USDC, and it was so cool. So we thought to add it this year and want to help developers think through how they can build innovative projects, embedding AI into the blockchain. So that's for cross-border payment. We've added qualification requirements. Basically what we're looking out for is we don't want you to spend the entire weekend to build a fully fledged app. It takes time to build something great. We want you to just spend time to build a reasonable MVP, something that works, something that you can demo to the team at the end of the hackathon, and something that really fits all these use cases that I'm working through, and you can document your processes, show us really nice GitHub commit. We don't want to see kind of like just one upload. We want to see steady commits, like, okay, you started on Friday, Saturday, Sunday. That shows us progress. It doesn't have to it doesn't have to be fully functional at the end. We want to just see that progress, right? And also give us feedback. So there's a survey link embedded into this qualification requirements page. Fill the survey. Let us know what product that you love. Let us know what tutorial you want from us. Let us know what you want in general. So you fill the survey, answer all the questions. So moving quickly to the second price category is best application for dollar access. It's really explanatory, and we have people already coming and pitching to us how they can even build for this price category. Essentially, what you're going to do is use the blockchain to provide global access to dollars. We all know that some regions are at disadvantage when it comes to accessing dollars. You can use the blockchain, USDC, and use the Circle developer platform, everything I talked about, programmable wallet, smart contract platform, gas station, embedded in your application to build something really cool. And again, we've got examples. We've got wallets, consumer applications, marketplaces applications, payment applications. And again, you can incorporate AI, and we've added examples of how that's possible. So the next one is crypto capital market. Crypto capital market, for a price of 2,000 USDC, winning price in this case, we've got examples of how you can use USDC as collateral for borrowing and lending digital assets, providing loans with USDC, and for trading use cases for crypto assets. And also we've added more examples in AI. This is a really special category, which is the last category. This category really talks about how to build for emerging use cases. We all know that some of these three use cases that we've talked about might be outside of what you're interested in working on. So we've added emerging use cases, and here we just want you to think wide, innovative, right? And we've added a ton of examples of how you can use USDC, programmable wallet. You can even combine that with AI. You can combine that with social platform, Web3 social platform that again supports financial incentive, how people can get paid. And another cool task that you can also add is, or another cool project that you can also work on is how you can use USDC to pay AI workers, which are digital workers on the internet, and we see blockchain actually shining with this use case. So that example, that project will fit right into this category. Again, so long as you ensure that you're using the Circle developer platform to build everything, I'm sure you'll be really considered in one of these use cases. And we have examples with AI, building retrieval augmented generation chatbots with, again, AI, and then the Circle developer platform, and then the blockchain. So we just want you to think outside of the box. So if you've got any DeFi protocol that you want to build, that would fit right into this category. And this category, the total price here is 4,000 USDC, and it's divided into two. We've got the first place for 2,500, and we've got the second place for 1,500. So everything I've talked about, where do you get help, right? Resources. So I know the time I have here is really short. Let me just point you to how you can get really good resources that our team has put together, sample applications, developer documentation. So if you come right here, and all these examples, we've added them right here, so you can go through and click on one of those links and be able to learn. But let me just quickly talk through this. So this sample app is actually a really cool sample app that we just launched. It's the Circle user controlled wallet sample app, and all the code that you need, you can find them right here. And this link points directly to the live demo. And this demo, sorry, one second. So this demo, you can see this demo. I'll just switch the wallet here to Polygon. Yeah, so this wallet, this demo actually shows how you can deposit USDC, send USDC from one address to another address, and it shows your balance. So this is an example of how programmable wallet actually works. And I'm sure if you need to go through the code, you've got everything right here, all the codes, all the examples. You can read through, see how we are integrating programmable wallet into a fully functional application, and that would help you think through how you can do that for your own use case. So don't worry, if you are looking for the link, it's embedded in the price page that I just walked through right here. One second. In the price page that I just walked through, yes, so you can, it's right there in one of those sample applications. I'll just double check again and include it. So another cool thing is that we included winning projects from the last hackathon. Crypto Relief, that was from London. YieldMe is a yield protocol that was built and won the prize during the hackathon. So the developer documentation, everything that you need here. So this is actually one of our learning platform that categorizes how you can build with user-controlled programmable wallets, developer-controlled programmable wallets, and how you can embed CCTP with programmable wallets. So CCTP is the cross-chain transfer protocol, and it lets you move USDC securely from one wallet, from one chain to another chain. So you can have USDC on, say, Avalanche. You can move it securely to Ethereum by natively burning and minting on another chain. So this guide actually walks through how you can use CCTP and how you can use it with programmable wallets. This walks through how you can use developer-controlled programmable wallets. So if this is your first time coming across all these products, we have all the learning materials that you need to really understand everything. So, and then we've got the developer documentation, all the APIs, everything that you need ready to go is embedded right here. So you can visit developers.circle.com. So I'll go back to my slide, and that's pretty much everything I want to walk through. And I thought to add this quote to motivate us, because I know it's a long weekend ahead of us, that we are builders, and we should remember that at the heart of every line of code lies the potential to change the world. Let's innovate with passion and build solutions that inspire the future. Thank you, everyone. So, questions?
I have one.
Yes, please.
Yeah, I checked the part programmable wallets, right?
Yeah.
And basically, I think the example was the backend in Next and the
Yeah.
front with the Xcode.
Yeah.
In the end, you reach the view that where you are able to send and receive.
Yeah, yeah.
The scene and test network. Is that enough to participate in the category, or actually you are expecting something, build something on top of that, or reaching that step where actually you are able to send and receive?
Yeah.
It would be enough.
That's a good question. So this is.
Can you repeat the question?
Oh, okay. So yeah. So what he's asking is that the sample app I just showed actually shows how to transfer USDC from one wallet to another. Is that expected? Is that something you can submit, or we want more from you guys? So to answer his question, that's a foundational sample app that shows you how the product works, right? So that's a really good starting point. You can build a use case that actually solves a problem, and again ties to all those categories that I listed, either for cross-border payments, either for dollar access, or crypto capital markets, or any emerging use case. So I would say build on top of the foundational sample apps. You already have something ready for you to go, right? So just think of a particular problem that maybe it could be in way, like it could be something that is particular to you, right? Maybe in your region, you're trying to solve a particular problem with blockchain. So this is a good starting point. Just build on top of it, following all the guys that I talked about. Any other, and also we've got sample apps in React Native. So if you're a mobile developer, or you can easily use our React Native sample apps as well. We have the documentation also linked in the price page, so you can get there quickly as well. Yeah. Any other question? Yeah.
Where can we get like faucets from USDC to
Yeah, faucet.circle.com. Faucet.circle.com.
Okay, but I think there is a limited amount, like daily amounts. 10 USDC.
Yeah.
Yeah, 10 USDC.
Come to the booth. We can work something for you.
Okay, thank you.
Yeah, you're welcome. Thank you, everyone. I wish you good luck.
Good? Hi guys, welcome to Block Scout Workshop. My name is Kirill, I'm head of research and an engineer at Block Scout. So if you haven't heard of Block Scout before, Block Scout is an open source blockchain explorer for EVM networks, rollups, hundreds of them. So the agenda for this workshop is just a couple of slides, why and what is Block Scout and why it's important to have something like that. And then we'll just go through different things you can use in this hackathon Block Scout for, different APIs, contract verification, and most importantly, how to win money in this hackathon. What's our bounty? We believe it's the easiest bounty throughout this hackathon, so thank you for coming. Just, yeah, should be pretty easy to get a part of it. So a couple of slides about why something like Block Scout is very important to have it in the industry, in the space. So in the past couple of months and years, we have seen this rapid growth in the number of EVM-compatible networks, rollups, with the advancements in the rollups like OP-Stack, Arbitrum, zkSync, and stuff like that. It's become super easy, super cheap to launch your own rollup, to launch your own EVM, and then there are just multiple rollup as a service provider who does that for you with just one click of a button. You can get in a few minutes your own rollup for DevNet, testnet, or even mainnet purposes, and to use it for whatever specific app requirements you have, build your own app chain on top of it. And so in this scheme where you can launch your own rollup within minutes, it's really important to have also for each of those rollup, you need to have some interface, some block explorer to explore what's happening on this rollup, to explore your transactions, your addresses, the token movements, etc. And so it's really evident that no proprietary or closed source solution will be able to catch up with this open source movement. And so you won't be able to ever launch a closed source solution in a couple of minutes, but you can do so with Block Scout. Maybe not in minutes, but in a couple of hours for sure. If you're doing it for the first time, you can launch the Block Explorer for your own newly launched rollups. Or there are also rollup as a service provider, or ourselves, we are providing the service as well for hosting the open source explorer for you. So what's the state of Block Scout today? Block Scout is the #1 most used open source, not just open source, but most used the Block Explorer in the number of networks. It's really hard to keep on updating these numbers because the networks are getting launched and turned off each day in tens or even hundreds. And so what's just some bullet points about the Block Scout success in this landscape. So Block Scout is fully open source on the backend side, on the front-end side. It's fully compatible with all of the popular rollup families like OP-Stack, Arbitrum, zkSync, etc. It's fully compatible with the EVM, mainnet, ETH mainnet L1 specification. We have a bunch of different modules like ENS support or different other ENS fork support on different networks, depending on what's important here and there. We have some specific modules for supporting account abstraction, for supporting data availability and blobs, and a lot of different other modules you can turn on and off within the Block Scout instances. Block Scout is user-friendly, it's simple to use, it's very natural, and especially when you see it on these hundreds of networks, users are becoming very familiar with its interface, so it's becoming easy to just use Block Scout in the new networks as well, because you have seen it on the past in other networks tens of times already. So now about what we have for the hackathon. So basically, okay, let's talk through the Block Scout APIs that you can use for the hackathon, which is basically one of the ways you can apply for a bounty. We have, I think I should have a separate slide. Weird, okay. So yeah, we have a bunch of different APIs for the Block Scout you can use within your builds. One of them is the REST and GraphQL compatible APIs. So that's the API itself that is powering the open source Block Scout UI. So whenever you see something happening in a Block Scout UI, like different transaction information, block info, token transfers, or account abstraction data, that's the same data can be extracted through this UI specification. We have all the docs, of course, in the Swaggers, so you can search through them. And so if you want to to get some specific part of the block scout data you can find in our UI. You can also incorporate it easily within your builds as well, just by finding the respective method in the REST API and use it right away. And the same stuff applies for the GraphQL, which is just slightly different format from the REST API standard. If you're more familiar with it, you can simply use it as well, no problem at all. Then the second piece of the API we have at Block Scout is an RPC-compatible API, which is designed to simplify the transition to Block Scout from other potentially closed source block explorers like EtherScan or other. So here we have this bunch of different modules. Basically, it's the same API as the REST API, but it's in a different format, which is fully compatible with the EtherScan or other closed source block explorers. So if you have some library that you are using for the block explorer interaction to fetch some data, to do something, to find some information, or if you already have some code interacting with the block scout through interacting with the block explorer by using some sort of this API, you can just replace the link with the specific RPC compatible API from Block Scout, and it will be fully, it should work as good as on any closed source block explorer here as well. And then the other solution we have at Block Scout is then basically a JSON RPC compatible API. So if you're familiar with all the methods that are available on the low level of the JSON RPC of the particular EVM node implementation, then you pretty much get all of this method for getting the logs, balances, transaction data, block data in the JSON RPC format. And these APIs are typically available through the dedicated JSON RPC providers like Infura, Anchor, Alchemy, or something like that. But we at Block Scout also are able to use our own infrastructure for hosting this data, and we are actually trying to expose the same data through the same compatible API as well. And the best use case for it, and also the way how we use it in our own UI, is as a fallback option for the existing JSON RPC provider. For example, here you can see the example for the popular WAGMI UI library, basically how to configure the fallback provider between multiple RPCs. You can put your injected wallet, then some public RPC provider, and if something happened to both of those, in the end, you can also put the fallback provider to the Block Scout so that your API and your UI are more robust, more redundant, are available regarding of what's happening on the network level. Then a bunch of other stuff we have at Block Scout is related with the contract verification. So just contract verification is, of course, a really important topic for the developers, and it's a really important topic for the security perspective of the EVM space. So just to give you a few words how the contract verification works in general, is that whenever you're trying to match a certain deployed contract that is currently unverified, you're submitting the source code that you used originally to deploy this contract, and we recompile it on our own infrastructure with the specific compiler settings you choose, like the version, optimizer settings, specific library addresses you used. And then we basically match the bytecodes together, and if we get a 100% match, then we just put this screen tick in the Block Explorer and put the source code, and then you're able to interact with the contract through the ABI and just read and write contracts, and review the source code for your own contracts or the contracts verified by other on-chain users. So in Block Scout, the way it works is that in many cases, we can also automatically import the source code from different third-party platforms if the contract is already verified. For example, if we are able to match that a duplicate contract with the same source code, with the same bytecode already exists on the same Block Scout instance, there is a good chance it will be automatically matched and verified without any user action needed. Then we are able to do the same with Sourcify and the shared Block Scout bytecode DB database, which is sharing this bytecode and source code information across different Block Scout instances. So if you are able to find the already verified contract on some other Block Scout instance or on Sourcify, there is a good chance it would be automatically imported without any manual source code submission requirement. And then one of the other features we are currently working on is called the Verifier Alliance, which is basically a step above on top of this Block Scout bytecode database, And there, the idea is to connect not only open source Block Scout instances we are hosting somewhere, but also to invite and connect other source code providers like Tenderly, other block explorers, or different analytical tools where you have here and there different forms for submission of contract source code. Here, the idea is to combine them in a single database in the uniform format. And so whenever a contract is verified somewhere, it's immediately getting available for interaction or for analytics in all connected partners and their platforms. So if you want to know more about Verifier Alliance, feel free to join the Telegram community for further updates on that matter. So if none of these automatic ways for the contract verification work, then unfortunately you have to do something through the CLI or manually through the UI to verify your contracts. So here we have a bunch of different ways how you can verify and submit your contract information to the Block Scout. Basically, they do the same thing, but in a slightly different manner and a slightly better in certain use cases. And so it's better to use some ways than the other for some particular use cases. So first, the simplest way, and it's probably the best way to do the contract verification for small and very simple contracts, potentially consisting of just one file with a few lines, or the best for the Viper contracts, which is a second popular non-solidity alternative for EVM contracts, is to submit the contracts through the Block Scout UI. Just pick the settings you used for the contract compilation, like the optimizer runs the compiler version, copy-paste the source code, and click verify, and after a few seconds, the contract will go through. Then there is a way to verify it through the different automation and custom verification logic. If you have some custom deployment pipelines, custom deployment scripts, then you can incorporate the Block Scout API for the verification directly, so that there are API methods that you attach the source code exactly in the same way as you did in the UI, put all the compilation settings and just make an API call instead of clicking the buttons in the UI. Then one of my popular ways is to go through Sourcify, so you can verify the contract there. If it's not verified, and then automatically import it Block Scout. So that's also a quick way to get contract verified in multiple places at once. Then there is some third-party tools that support the Block Scout verification, like Catapulta, which is basically, I think, the best way to proceed with the contract verification. If you have some really complex deployments consisting of huge number of contracts across different chains, and you just don't want to do it manually, these tools make it easier and faster to just optimize this across different chains, explorers, etc. And the last is probably the most generic way to approach the contract verification is to use our integrations with the Foundry or Hardhat, which I believe are currently two most popular developer frameworks for Solidity contracts. And so there, through just specifying a couple of CLI options and pointing the developer framework to the concrete Block Scout instance URL, it will be also relatively easy to automatically verify the Block Scout contract whenever you're using those tools to write the deployment or deployment scripts, basically. And then one of the other features we have with Block Scout is support for different proxy patterns. So proxy patterns is a very popular way to write and deploy contracts within the Solidity landscape. So we support this huge number of different standards. We support minimal proxies, different proxies based on the specific storage slot parameter, ABI method-based proxy, and diamond proxy, custom proxy implementation, for example, Gnosis Safe. So if you're using any of these proxy formats, it also should be automatically verified within Block Scout whenever you verify both the proxy contract itself and the implementation. And the Block Scout will link those contracts together and simplify how you can interact on the contract page with those kind of contracts. So now to the good stuff. So basically what we have for the bounty is our bounty is very simple, very straightforward. We just have this pool price of $20,000 for all projects that successfully use the Block Scout throughout their builds. So basically, if you just use the Block Scout as a way to link user to the Block Explorer for their transaction that they made through your D app, to the contracts they interacted with, to their address profiles, or to something else, then you qualify. If you verify your contracts in the Block Scout and show it to us during the presentation, that also make you qualify. If you use any of the above mentioned APIs, like the REST, RPC, GraphQL, or just put the JSON RPC fallback API for the Block Scout, you also qualify. And also as an optional bonus, you can also prepare and submit your DApp in the DApp Scout Marketplace, which is the DApp Marketplace on the Block Scout. So this would just allow your DApp to be available to more users through the Block Scout Marketplace. And then the most important stuff of all, you just need to show how you use Block Scout and how you incorporated it during the presentation to be 100% eligible.
So sorry, you need to meet all the requirements or one of the requirements?
It's important to meet one of the first three, and then, of course, to show it to us and to specifically clarify it in the project submission, how you use to show the screenshots, or even better, to show during the live demo, then you can be 100% sure. And this bounty will be split among all of the qualifying projects, so we have like 20 of them, then each one receives 1,000. Yeah, and as one more bonus for what happens with Block Scout after the hackathon, we are also starting up and booting up the ambassadorship program for Block Scout and recruiting different ambassadors for creating social media content, for representing Block Scout in your local communities, for participating in different events as part of the Block Scout brand. So if you are interested in something like that and you want to apply and potentially also earn some money for that, please fill out the form and we'll get in touch very soon after the hackathon with more details on that matter. So yeah, that was pretty much it. Happy hacking, and if you have any more questions, please feel free to ask. Go.
Are you happy with using Elixir for Block Scout?
Yeah, so the question is, are we happy with using Elixir? Yeah, Block Scout is open source, and it's currently consisting of two main parts: the core backend, which is written in Elixir, and we also have a bunch of microservices written in Rust, and then the front end is written on Next.js and React. So, are we happy with using Elixir? I think, yeah, why not? Elixir is a kind of unusual language, of course, and you don't meet it a lot, and maybe for someone it makes it harder to contribute, but at the same time also it makes Block Scout unique, makes it interesting for a lot of developers to look through its code base, to learn something new. It's interesting to just, nobody wants to contribute to another JavaScript project sometimes, but when you see something in Elixir, that maybe makes it more interesting to you to contribute something. So yeah, I guess we are still happy. Yes, yes, sure.
Does the API offer labels to addresses? So can I see like if the address belongs to like Binance or like some Uniswap project or something?
Yeah, the question was about is the API display some information about the tags on the addresses? The answer is yes. We have the API and the microservice for tracking different tags related to the different addresses. We have an service responsible for linking addresses with the ENS and alternative name service providers, so you get those tags as well. But yeah, for stuff like Binance addresses, whenever something is labeled somewhere and we imported it, yeah, there is an API for that.
So is the service of Block Scout only self-hosted possible, and is the self-hosting having some requirements on the system we have set it up?
No, there is no requirement to set up your own Block Scout or whatever. We have like these hundreds of hosted instances of Block Scout that are hosted. Some of them are hosted by us, around like 50 of them. Some of them are hosted by Rollup as a service providers or other teams as well. So unless you're planning to launch your own Rollup throughout this hackathon, then of course you can spend some time to launch the block scout and we can help you with that. But if you're using the existing chains, then there is no need to do that.
Okay, there are chains that you can just use the APIs.
Yes, yes, for most of the popular chains and rollups, Optimism, Mainnet, Testnet, Base, Polygon, every one of them has the block scout instance.
Okay, thanks.
Okay, I guess we are done. Thank you very much. Happy hacking.
All right, hey everyone. Thank you for coming to the talk. I am Sauce. I go by Sauce. I work at the Uniswap Foundation as a DevRel / protocol engineer on V4. Today I'm going to be kind of doing a code walkthrough on dynamic fees. It's one of like the many features of V4. If you're looking for a more beginner intro into hooks, you can come find me at the booth in the main auditorium afterwards. But so today we have like this demo use case of changing the pool fee as a function of gas price. And so today we'll be just learning like what are dynamic fees in V4, like what are some of the use cases that people are using them for, how does V4 sort of handle these under the hood, and then we'll kind of do like a nice little code walkthrough on dynamic fees. So in V4, or I guess in V3, the fee tiers are fixed to like 4 values. In V4, we also support dynamic fees, and this what it really means is it lets you arbitrarily adjust the fee value up and down without requiring users to like migrate liquidity or change up like their positions. And this is arbitrarily calculated inside of a hook. I know there's some AMMs out there that do dynamic fees, but they sort of enshrine some sort of hard-coded logic. But in V4, it's up to the developer to implement and how they want to set the fee. These are settable at the transaction level, so on every swap you could change the fee if you wanted to. You could do it at the block, or some arbitrary infrequent interview, like once a week, once a month, so on and so forth. And so in terms of like the use cases that we're seeing with developers building on V4, a lot of them seem to be interested around creating more efficient AMMs. You can sort of change the incentive dynamics. So in our case, as gas price goes up, as it's more expensive to swap, we can make it cheaper for the users to incentivize volume. I've seen some examples of people using dynamic fees for like token issuance, where like if a token is new and as it matures, you can kind of like decay its fee value. So those are some of the ideas with dynamic fees in V4. So how to do it in V4? There's 2 ways. The first way is what we call like cash dynamic fees. And there's a function in the core contracts that say like, hey, for this pool, for this trading pair, the fee value is now this, right? This is a write into contract storage so that whenever users swap, we read this value from contract storage. This is really good for infrequent updates. So if you're changing at the block level / like maybe like once a week, you can have somebody come in and say like, hey, the fee's changed. After working with a lot of developers, they have been increasingly more interested in changing the swap fee on like every transaction. And so we came up with this new implementation called like the override fee or the non-cached fee. And what this does is it's in your before swap function, you're returning a value that is used for that transaction itself. This value is not written to contract storage and it's handled in memory. So it's a lot cheaper for cases where you want to change the fee on every swap. And I'll be going into like examples on how both of them work. So in V4, whenever you define a pool, right, a pool is made up of which 2 currencies are being traded, which tokens are being traded, the fee value, and the hook contract. And so to initialize a dynamic fee pool, you just need to set the fee value to like some special flag. This communicates to the core contract saying like, hey, the fee can go up and it can go down. This setup is the same for both ways of doing dynamic fees, so just something to be aware of. And so how cash dynamic fees work in V4 is there's the value is saved in slot 0, so whenever you call this function on the core contract, it says like, hey, this key has a new fee at this value. There's some checks that happen, so like one, the call to this has to originate from your hook, so nobody can come in and say like, hey, my enemy's pool should be 100% fee. So it has to come from your own hook. It has to be within 0 to 100%. And those are really the only 2 conditions for updating the storage value, which happens in the last line. The override fee, so this is what it looks like inside of a hook contract. So you define this function called before swap, and what you can do in before swap is run some sort of fee calculation. It's kind of just hidden under get fee. And what you do in the return is you need to append a special flag on it so that whenever you return it to the core contract, The core contract also runs the same checks, like is it between 0 and 100%, and does it have this like special flag? And if so, that fee value is used for that swap. And the value is not saved to storage, so it's a lot cheaper to use. Cool, so I'm just gonna go over our example today. So if we wanna set a fee based on gas price, we can create something where, if the gas price is going up, we'll make it cheaper for swappers, so decreasing the fee. You could argue that it should be the other way, where if gas price is going up, it's more like the market's more volatile, LPs are at higher risk, the fee should be going higher, but in our case, we're gonna try to incentivize swappers here. Some more information around it is we're gonna set like a base amount, and then dependent on if gas is trending up, we'll cut that fee in half, and if gas is trending down, we'll double it. And like I said, there's obviously more complex designs and more production style implementations that you could do. So I guess did not prepare this. So the people that are new in the room, this is what a hook contract looks like. It's a contract that like inherits a specific interface from base hook. You kind of define which functions you're going to be implementing. And in our case, we're doing before swap and after swap, but there's a ton of other sort of customizations that you can do in V4. And so in before initialize, so if you wanted to create a pool, like you launch a new token, I'm pairing it with ETH, and I'm going to take this off-the-shelf hook. I can create a pool using it, but because this is a dynamic fee hook, I check to make sure that I've set it up correctly. So before the pool gets created, we check to see that the dynamic fee value is set correctly. Otherwise, it will revert and kind of prevent you from shooting yourself in the foot. The before swap here is super simple. It's literally from my slides, but we can kind of go into some of the logic. So to read the fee, you can go into assembly and read the gas price, and then if gas price is 10% above the moving average, then we'll return a fee that's cheaper. If gas price is 10% less than the moving average, then we'll double the fee. And so this value, like I said, gets returned to the pool manager contract, which then is used to apply to the swappers. There's some logic here that I can glaze over, but this is kind of how we update the moving average, and it's like super flexible in the sense that like, if you wanted to make a dynamic fee from a Chainlink price, you totally could. You can do a lot of cool arbitrary things. Anything that you do in Solidity, you could do to set your fee. I will touch in after swap here. So this is a function that gets called after the swap happens, and in our case, we're just going to update the moving average such that on every swap, it's like the calculation is live. I'll go into testing here very briefly. I think testing is super important for at least our bounties. Our bounties are less concerned about like front ends and presentation, and they're more, we like to consider like working code. And so I'll kind of just quickly go into what testing a hook looks like. So there's like some setup code here where you kind of deploy V4. This is where you're like deploying your hook here to a specific address. We have cheat codes to set the gas price because we're trying to test that the fee was applied, so we based on gas price. We're creating the pool, we add liquidity here. And so in our test here, we're testing the base case where the current gas price is 10, and then you can see that we're executing a swap here and like sort of checking the balances. Then we decrease the price, we run a swap, and essentially if we run this, it might be hard to see. It's a little hard to see, but you can see like the base fee output is an output, and then whenever gas goes up, or no, whenever gas goes down, you're seeing a higher fee being charged, so the output amount is less. And so this is kind of like the stuff that we like to see for submissions. And go back to here. You can find our docs. They're new, but it's available at notreadyyet.uniswapfoundation.org. And I'm on Telegram, on Twitter. You guys can reach me at SaucePoint, and I can open up the floor to any questions. The cheat, are these custom?
I don't know, they look custom to me. Yeah.
These, yeah, this was hardX code, but I think, yeah, I think the cheat codes in Foundry let you adjust gas price.
Okay.
They can change, you can change a lot with the cheat codes, like block number too. Like, so if you wanted to do a decaying fee, right, you can update your block number, or maybe even block timestamp too.
You mentioned now, for an example, it's not like completely accessible for us.
Oh, it is. It should be.
We have like bootstrap.
Yeah. Let's see. It was under. I think it was gas price hook. Yeah. If you wanted to do, yeah, it's under gas price hook. Did he take this from template? Let's see. I didn't. I have a starter repo called V4 template under Uniswap Foundation. This is also a great resource for creating a hook. It sets up all your dependencies, gives you a base contract, a base hook to work with. Also sets up tests for you to also just get quickly started.
One question, I'm still a beginner, this is Uniswap before. But when I call the hook, do I expect like a fast reply? Because calling an Oracle token might be later. So.
Yeah. So yeah. Hooks are invoked atomically. So what happens is it's like the user is sending a swap, so it touches a swap router. Swap router then calls pool manager, and then pool manager will then call your hook. And it all happens within one transaction of a swap. Yeah.
Ask you, if there are multiple pools, does any contract guarantee that they're all going to get swept through? So what if I have a pool inside of this a hook, but nobody uses my pool, and they swap another pool? What will happen?
In that case, like your hook, yeah. If the order or if the swap doesn't go through your pool, then your hook doesn't get called. Essentially, yeah, it's kind of like a routing problem, right? And in the sense that like if you're a hook developer and you deploy a pool, it's like you're not guaranteed to have volume go through it. It kind of is a function of liquidity and how like accurate or like how good you're quoting the assets.
So who decides? The UI?
It'll be the UI deciding. You can run a Uniswap X filler in production to point to your pool, and we're going to be doing work around that so that hook developers can receive order flow.
Thanks. I had a question about no-op swaps. If you're doing no-op, should you always do it in before swap? Or?
Yes. Yeah. I'll try not to go into it, but yeah. I think it only works on exact input swap because you need to take the input amount.
Yeah.
No. So you had a question?
Yeah. How arbitrary can you make the logic within a hook? Like, for example, could you have like a hook that it checks if there's like really low liquidity relative to your order, and it says actually it'd be better if you deposit it to a vault instead. And just grab
Essentially, this is like the dumbest hook in the world. It counts how many times this function got called. But instead of this, you could do like any sort of solidity here. And there's getter functions, which would let you read the liquidity of a pool. You could read like the fee volume of a pool. What else? I mean, I guess that's like kind of like the two major things of a pool is its liquidity and its fees.
One more question. If I go lock the pool, want to do a swap, and then when I want to withdraw liquidity from the same pool, will that allow me, or do I have to kind of disable something? Can I touch the LP withdrawal?
You can, yeah. So like in before swap, you could be a bad actor and you could like front run somebody. After swap, like the way limit order works in V4 is you are a one tick wide position. And if the swap crosses your position, your assets flip from token 0 to token 1. And then inside after swap, it's closing that position. It's like withdrawing it. You could do things like in before swap, where if you see a large swap come in, you could like concentrate a crap ton of liquidity around the spot price. It makes quoting and stuff like very difficult. And we're still doing a lot of research on like what that looks like in production, but it's possible to do. Yeah.
So in the after swap, I can withdraw liquidity from the same pool?
Yeah. Yeah.
So, can you make it like a time base where you add liquidity, and if after the time passes, you remove the liquidity, meaning that in the modifier that we call before swap and after swap, it has a time between those, or you need to call a keeper?
You could do it before swap and after swap. So before every swap, like let's say this hook contract owned tokens or whatever, before every swap you could add like a tiny little bit of liquidity every swap. You can kind of, yeah, treat before swap and after swap as like, you could plug in like a keeper job. Like there's one thing that you could do where like after swap, if the price moved substantially and you're like deposited in Compound or something like that, like you're a lender on Compound and you're like, oh shoot, like the price is moving like super fast and I'm scared of like Compound accruing bad debt, you could have a hook like withdraw your deposit from Compound. Like it's entirely arbitrary solidity. So there's a bunch of cool things that you could do. Yeah. I think you had a question?
How do the approvals for the token work? So the user has to approve for the swap router, which then is able to transfer tokens to the hook?
Yeah, yeah. So approvals, you'd approve on the swap router, like in V2 and V3. Yeah. And yeah.
Is it possible like to merge between the hooks with flash swap as well?
Yeah. You could flash swap and sort of borrow money and move the prices and stuff. So, yeah.
There's like a hook that is after add liquidity or after remove liquidity, I think.
Mm-hmm.
And it has a delta that it has to return.
Yeah.
I'm not sure what I understand what that delta
Yeah, the delta stuff is hard to explain super quickly, but essentially it's part of this thing called like custom accounting. And what it does is it lets the hook essentially take a portion of the liquidity. So like after you remove liquidity, the hook could take some of the principal capital. It could also take some of the fees. And like some of the things that we're thinking about is like, if you have a just-in-time position, you can sort of punish these JIT people by taking their fees. And so you could do that in after remove liquidity using that like delta flag, essentially, where the hook said like, I took X amount of tokens, and what that means is the hook needs to return this value to signal to the pool manager saying like, hey, I took this amount.
And the balance goes to the hook contract, right? It's
Correct.
When you transfer it, it's just that
Correct.
it says like now
Yeah.
the hook contract is balance.
The hook doesn't have to take the balance. It could take it to a treasury. It could take it to an EOA. The bookkeeping is held by the pool manager saying like, hey, this hook did something. It took money, and the pool manager doesn't care where it took the money to, right?
So this delta is like LP denominated surplus or deficit. Is that what it is?
Yes, that's a good way of. Yeah. Were there any other questions? You guys got some good questions. So like, the slides were a little too basic, huh? Fuck.
Can I ask more?
Mm-hmm.
Sorry,
Yeah, it's okay. Yeah.
What's the difference between this and pancake swap V4? Why not? It's about science, right?
Yeah, I'm not too familiar with Pancake Swap's implementation. I will say that it's slightly different. The hook interfaces are suspiciously similar, but that's all I could really say about it, I think. Well, cool. Thank you guys for coming to my talk. I'm in the main auditorium, so.
Awesome. Cool. Awesome. We'll give people another minute just to roll on in and then get started. Awesome. Cool. Well, thank you guys all for coming. I know most of you have traveled a pretty long way to be here, so super excited to see what gets built in the next couple of days. At a high level, this workshop will be going through what is Layer 0, how can you get started building on it, what is the full stack of things that you can create using the tech, and going through a little bit more in detail some code to get you guys started. So without further ado, my name's Matt. I'm a developer ecosystem lead on our DevRel team at Layer 0 Labs. You can follow me at Uncrackable on Twitter. Feel free to ping me at any point during the weekend if you guys have any issues that you run into or need support. I'll be online for most of it. I always start off these presentations with the physical world representation of a bridge because I think it's important. Most of us have seen a bridge, but we probably don't think that deeply about what is a bridge doing at a high level. Obviously, it's connecting groups of people on different places, right? But more than just the people that's being connected, it's the information that they hold. Having a bridge, at least in historical times, was incredibly valuable because it meant that you could then coordinate the transfer of goods and services. And with the transfer of goods and services came the financialization of those services. So bridges, in general, are very, very useful for moving information and value. With cross-chain, it's no different. If we look at the blockchain industry today, developers and users are constantly facing trade-offs depending on what chain you want to go to, whether it's an L1 or an L2, depending about the finality on that chain and the time it takes for a transaction to be included in the block, the cost of the block space itself. Each of these things make you as a developer face different realities about what you can and cannot build on each blockchain. At a high level, if we talk about maybe the most common use case for blockchains today, the movement of value, right? This is a simple ERC20 contract on Linea. At a high level, when we think about moving assets, right, from point A to point B, we like to think of it as an actual movement, but really all we're doing is updating the ledger state. We're saying, I want to deduct an amount of balance from one user and then credit that balance to a destination. But as soon as you move to a cross-chain environment, that immediately becomes a lot more complicated. Each of these chains are isolated. They don't have any context about the other network. And so as a developer, we need to think about a way for us to call some sort of transfer function, know that the assets in question have been debited for sure, and then somehow relay that message over to the destination network and instruct it to call some function that receives those tokens for the intended user. So this is the domain space that we're working with, especially when it comes to value transfer. But if you're just working on that kind of value transfer level, you need to also ensure that this cannot be abused, right? If we just allow anyone to make that receive call without good confirmation that this is a valid function call from a source blockchain, you can easily wreck the network and wreck the protocol. In general, the way that we solve this over time is with the concept of monolithic bridge security. You can think about this in the center here as some centralized provider that's listening to events on a source chain and writing them directly on a destination. You could think about this as a collection of different verifiers. You could think about this as a middle chain where the central verification schema is just a middle chain bridge. But in general, there would be some entity in the middle that you relied on and you basically put all of your trust in to ensure that they were going to be able to verify and deliver the messages on your behalf. But again, we have this problem here where if that is such an easy solution to the cross-chain space, why are so few people building on more than one chain right now? This is from the Electric Capital Developer Report, and these numbers have been going up. More and more people are becoming familiar with cross-chain development, but the major problem I think right now is that we don't often think about what happens when these security guarantees fail or backfire. As soon as your security goes down, not only are you, the single application, at risk, but every application on that network is simultaneously at risk that uses the protocol in the middle. This could be due to a number of things, whether it's just a flat out centralized service moving messages between chains. This could be due to the client software used to secure each of the validators that sign off on a message if that client software has a backdoor, or it could just be due flat out to a lack of node diversity, which is how the Axie Infinity Bridge hack happened. So in general, the main problem is that once a messaging protocol fails for bridges, every application that touches that messaging protocol fails as well. And this has been a stark reality that we've seen in the last probably decade for blockchain development, where the majority of hacks and exploits we see that have the largest value attack are due to this centralized or monolithic bridge security. So in my eyes, the way I like to frame it is, if you think of Ethereum as a dark forest, cross-chain is a dark ocean. You have each of these islands that don't know about each other, and the only way for you to get knowledge from one chain to another is to rely on some actor to control that message and pass it through to the destination. And if a malicious actor controls the port of entry for that island, the island itself faces an existential threat. Simultaneously, if a centralized entity accidentally destroys the port via some upgrade to the contract or the interface itself, the island also faces an existential threat from not being able to get reliable information to the chain. So the way that we see layer 0 is addressing these two issues. The one of, if the protocol fails, every application fails, and two, the destruction of the actual interface that developers use because of the upgradability of the contract interface. Layer 0 is a permissionless protocol, meaning that layer 0, the entity that owns the endpoint contracts, cannot block or whitelist or blacklist anyone from using the contracts themselves. The endpoint interface is fully immutable and permissionless for anyone to use. And furthermore, it's censorship resistant in that once a message is emitted from a source blockchain, an arbitrary user or arbitrary actor can't strike that message down without invalidating the protocol guarantees. And finally, as I mentioned before, it's immutable. This people go over quite a bit, but I think it's more beneficial to probably see it in code. From the protocol stack for just majority of message passing on bridges, the way that message passing works is that there is at a low level an omni-chain messaging layer. The way that this layer works is that it is focused mainly on the verification of messages from point A to point B. This is that collection of different signers, the testers, the middle chain bridge, whatever it may be. Layer 0 allows the application to select the block confirmations. You have to wait on a source chain, the required verifiers in the stack, the optional verifiers as part of that stack, and the threshold needed for a message to be considered verified. We'll dive in a little bit more into what that actually looks like. On top of this low-level layer for verification, we need a way to actually route function calls. So this omni-chain function call layer operates on top of the message verifications and allows the app owner to control the amount of gas limit, message value, order of execution, and the executor to use for each call. We have two different call methods that you can use. The LZ receive execution, which is just part of the iLayer 0 receiver interface. This is for receiving any message packets on a destination chain, and iLayer 0 composer. We'll dive in a little bit deeper too into that as well. And finally, the most important bit for the application developer, what you guys will be hacking on, this app standard layer. So applications on top of these two other parts of the stack will essentially use these different functions to enable different use cases within different EVM environments. We have an OAP contract standard that lets you move arbitrary bytes between point A and point B. We have an OFT, omni-chain fungible token standard for moving ERC20 token balances, and an ONFT standard, which lets you move NFT transfers between chains. At a high level, this is the send workflow. An application, whenever they want to use layer 0, will create a call on the layer 0 endpoint called endpoint.send. This call allows you to specify a message in bytes that you want to deliver to the destination chain. You will specify the destination chain identifier as an endpoint ID, and you will provide a send configuration of what off-chain stack you want to use to deliver that message on your behalf for you. As part of that configuration, you can decide the amount of block confirmations that must be waited on the source chain before this off-chain stack gets started, and you can assign the job to specific verifiers and an executor of your choice. Today, Layer 0 has 30 plus different verifiers to choose from, And as part of the security guarantee, you're able to choose the required number of verifiers. So in this case, let's say we ping 4 different decentralized verifier networks about this message in particular. 3 out of 4 of them have to sign off on the message's integrity. And this is enforced by the application from what they set on the destination chain. Again, it matches your send config. So in the send workflow, we say wait this many confirmations. The receive config enforces it. It also enforces the expected DVNs that are meant to sign off on the message and that threshold for security. Once the message has been verified, you can simply have an executor, whether that's a user calling the endpoint directly or a automated executor that layer 0 runs, automatically deliver the message on their behalf with an automated gas abstraction for them. So this is a high level at the workflow. You initiate a send transaction, it emits to some off-chain entities based on your configuration. Your receiving app enforces that it matches the configuration you expect. And then finally, you execute that message through to the destination chain. So this kind of builds into us what we think of as this omni-chain application, the idea that any smart contract on any chain just has to interact with a single layer 0 endpoint that is already deployed on that network and can be routed to any other blockchain network within the stack. Furthermore, we are able to configure things a little bit more deeply. Each application has a concept of this bytes message, right? So in general, if you're used to ABI encoding bytes on Solidity, the way that it works is just ABI encode any data type that you want to deliver to the destination chain. From there, when you have the receiving call being made to the destination app, you will decode that message and extract the bytes inputs with ABI decode. For the OFT standard, there's a message codec library called messagecodec.sol that I recommend you guys look into. It'll give you a bit more advanced usage for how to splice bytes out if you're interested. And finally, within the app, there's a final little piece of application layer security. Each application sets a peer address for that pathway. So you can see here on the send side, we select this destination endpoint that we want to deliver to. And what this security, this peer is doing is I'm saying within my application, from this endpoint ID, I want to ensure that this is the address that's sending the message. So it enforces once again that you have the verifiers that are checking the integrity of the actual message itself, and you know that the origin is coming from the place you expect to prevent any invariance. Again, same thing works on the send side. We check the peer and we just say get peer or revert for that destination to ensure that you have configured a correct peer on both chains. Going a little bit deeper into the tech stack, the way that the layer 0 endpoint actually works is that it's an immutable smart contract interface. And what I mean is layer 0, once this endpoint is deployed, cannot arbitrarily change configurations to rug your application. The way that your application interacts with the endpoint is that you will use it for both the send and receiving function calls, but you'll also use it to set your configuration. Once an app has set a selection of decentralized verifier networks by an array of their addresses and set the executor by its address, there's nothing layer 0 can do from our end to change it. So entirely permissionless and entirely owned by the application. Underneath the endpoint, we have a secondary contract called a message library. You might be wondering, why is there a layer 0 v2 if I haven't heard of layer 0 v1? Layer 0 v1, without getting too into it, was a separate collection of smart contracts that enabled you to instead choose an oracle and a relayer. When we decided to create endpoint v2, we thought, well, we want to bring some of the benefits of this configurable security stack and separate execution logic to the existing apps that were already built. And so we added these appendable smart contracts, these message libraries. What this allowed you to do is, as an application, you could call this function and change which library I was using for my application, enabled you to upgrade from this Oracle relayer setup to a collection of security from these different DVN providers and executor. And so it was a guarantee for developers that they still had an upgrade path to the latest and greatest security without using upgradable contracts, just appendable configurations that the application owner set. Nothing forces a user to use this configuration once it's set. It is purely optional and something that they are able to configure at their choice. Going a little bit deeper, we have this idea of DVNs, right? What are DVNs? Well, In general, when we talk about DVNs, it can technically be anything. Most bridges have some method for essentially listening to the source chain, learning about the state, and writing that state to the destination. And so as an application, this provides you a way to not only future-proof your app by, if a latest and greatest verification schema comes out that moves messages cheaper, faster, and more securely, you can add it to your security stack. But it means that you as the app owner aren't forced to accept a one-size-fits-all model for security for cross-chain messaging. You're able to easily configure any number and type of verification within your app and be able to ensure that if something better comes out that beats all of them on price, your application isn't stuck and forced to redeploy contracts or completely change the infrastructure underneath. So with all that in mind, taking a more kind of stepped back approach to token transfers, the way that Layer 0 does it is pretty straightforward. You'll deploy an OFT contract on each chain you want to connect, in this case, Linea and Ethereum. And when a user interacts with that OFT contract, all it's doing is calling a debit method, which interacts with the underlying ERC20 token interface to burn those tokens on a source chain, route that message from the Layer 0 endpoint, given the OFT's unique security stack that they've configured, and then once it's executed, credit those tokens to a destination address for the amount listed. And what that means is, going back to our previous example, if one of these verifier networks outright fails, your application at worst is simply paused until you reconfigure a new security network and your threshold, or at best is completely uninterrupted, right? If this is a 2 out of 3 security setup, your application has not been halted at all, and it gives you a future-proof path to avoid any issues at the verification layer, which is ultimately the most important. Outside of that, Layer 0 lets you configure a lot of other settings that we talked about. For example, the block confirmations, the message execution for whether it's automatic, where a user only pays in a source gas token and it'll automatically be swapped for the destination native gas that you need. Or if a user wants to make that call manually, they can do that as well. Deeper on those execution gas settings, we have specifically the amount of gas limit and message value for the receive call, a composable call, which I'll dive into in the code example, and strict nonce ordering if you want to enforce that messages have to be delivered in a specific order. I recommend checking out the docs or coming to the booth afterward if you want a deeper dive into kind of what these configure options mean. But finally, I think the thing we care about mainly is what this all builds up to. The omni-chain tech stack for us is a way for any application use case, whether it's DeFi, SocialFi, gaming, Oracle feeds, identity, to be built in a way where they can control the not only type of security that they're using, the type of execution logic that they hold, and ensure that they're interacting with a common interface across every single chain. You don't have to learn a completely new chain interface or application interface to unlock new security. Instead, you can have a simple, immutable interface that you've always used for your application and easily configure new types of security within your existing apps. So I'm going to jump past these really quick because I'm short on time. If you want to scan this QR code, it'll be the repo that I start going through in the next 1 to 2 minutes. The last 10 minutes of this talk will just be going through an example design pattern repo to kind of show you what is the design space that Layer 0 has, and hopefully the demo code doesn't break, but we should be good to go. Awesome. So switching over here, let's just take a look at this repo. Before I dive in, let me show you how you guys will actually get started building on Layer 0. If you want to use our CLI tool, which I highly recommend, the way you'll start is you'll run npx create lzoapp at latest. This will ask you a couple questions. First, what do you want to call your project? I'm going to call this new lzoapp, and it'll have you choose a selection between an OFT template or an OAP template. In this case, I will choose OFT. It'll also ask for what package manager. I'm going to use Yarn because I like Yarn, and then install some dependencies. For me, it's going to complain about Node because I forgot to switch it, so make sure you're using Node version 18. And if you run into any issues like that, all you need to do is cd into the application, run Yarn, and it will pull down all the dependencies that you need. Fortunately, though, I have another package that I've already set up, so we don't have to realize that. And one of the things that I think is most helpful about this repo setup is that inside, it's a hybrid repo that contains both hard hat and Foundry. So you can use common hard hat tasks that you're familiar with. You can do common Foundry testing. And I'm going to go through 3 contracts. First, at a high level, how do I deploy my OFT? This is a strictly vanilla OFT. The only change I've made is I've added this mint function to mint 100 tokens to the message sender. Within this repo, what's really cool is we kind of expected you guys to start doing a lot of these deployments out of the box. So you can run, it's still going to complain about Node, which I'm going to cancel. I'm just going to switch here to make sure we're set. Perfect. So I'll run LZ deploy. What it'll do is it'll automatically compile your hard hat artifacts, pull them in, and it's going to read from your hard hat config. In this case, I've already set it up to include my Sepolia endpoint, my Arbitrum Sepolia endpoint. This is just a handy package that comes standard with the repo to let you pull down what the endpoint identifiers are. From here, I'll hit, oh, don't want to hit enter there. I want to hit enter in the terminal. It'll ask what deploy scripts I want to use. In this case, I'm just going to use my OFT deploy scripts, hit continue. Public RPCs will do their thing. Great, I've just deployed 2 contract addresses on Arbitrum Sepolia and 1 on Sepolia. Now, once this is set, I ideally want to be able to actually configure them to work together. So I'm going to use another handy configuration called npx hardhat lz oap config init. With this, I'm going to pass in the location that I want my configuration to be. In this case, I'll do it as example layer 0 config.ts. And I'm also going to pass it a contract name. In this case, I'm going to pass it myOFT. That's the contract I'm working with. And this will, again, ask me to select what networks I want to populate it for. And it will generate this file in my working directory. It will pop out here in just a moment. Awesome. So what does this actually give us? If we format this document, we can see it sets up for us first an instance of the contract on each chain as an object itself. Arbitrum Sepolia, Sepolia contract, tells us the endpoint we're working with. And then it will automatically bring in the default configurations for this pathway. Default configurations, you can be thought of as like placeholders that layer 0 has set for you just to get tested and quickly started. These can be changed though with all of the addresses available in our docs if you go and look at the deployed contracts page. In this case, the ones that we care about are how do we make sure we can send a message from Arbitrum Sepolia and then receive it on Sepolia. I'm actually going to comment this part out just so you can see. So we have a send config and we have a receive config. The way you can think about it is that in this top part of the repo, for Arbitrum Sepolia to Sepolia, I'm just specifying a send configuration that will call some functions on Arbitrum Sepolia as the from contract. It'll set what my required DVN is, the block confirmations I need to wait, and then similarly for the Sepolia contract, it will provide its receive configuration. The important thing is that this receive configuration matches this send configuration, right? So from Arbitrum to Sepolia, we're sending. From Sepolia to Arbitrum Sepolia, we're receiving. Awesome. From there, I can run npx lz oap wire, pass in the oap config that I have provided, example.layer0.config.ts. Don't want to update Slack right now. And from there, we can just see it go through, and it will provide me with a little preview of the transactions about to sign. Oh, it's already wired because I've done this deployment once. Great. If you haven't done this deployment, it will basically output and check what that looks like from your end, but we are good to go. In that case, I'm just going to do a simple send transfer. So I've included a simple task in this repo to send tokens. You can see how this task works. It just takes in an amount I want to send, in this case 1 token, to my destination Sepolia, to this wallet address from this network, Arbitrum Sepolia. From here, I can hit send. Public RPCs will do their thing. We'll send 1 token to the network, and then we'll get this send transaction initiated with a layer 0 scan link. So I'm going to open this up. We can see here that once it's indexed on the source chain, it'll immediately populate in layer 0 scan. You can see the messages in flight. The cargo is 1 mock OFT from this address and you can see it went to the burn address here. You can see which applications are in it, what gas is being used on the destination chain, and we can wait for this message to be delivered. I don't want to waste any time, so while that's being delivered, let's see if we can jump back over here. Perfect. I have 3 other example contracts in this repo that aren't basic OFTs. These are some more advanced design patterns that you guys can implement. The first one is an ABA type call. So this is for you to send a transaction that returns an acknowledgement back to the original sender. The way this contract works at a high level is that we basically will take in a couple parameters when we do this send function. We'll take in the destination that we're sending to, in this case a string message, and some gas settings that I've specified. I have the ability to add on top of some required gas settings, some optional ones that I'm having the developer use. So I would play around with this in the repo when you get a chance. From there, we initialize a send call. It will emit message sent. And then on the receive side, decode that message, check if the message type is this return acknowledgement, and return a secondary send call back to the original sender, which you can see here. We're using this origin struct provided as part of the receive call here. So returning back to the sender a message, in this case a predefined one that I've said, chain B says goodbye. So I don't have this one deployed. Instead, what I'm going to do is actually take advantage of the Foundry test helper that we've built. We have a special test helper contract that you can use in your Foundry unit tests to kind of mock layer 0 implementations within Foundry Forge. In this case, we want to do test ABA, and we're going to crank the verbosity on this one. It's going to compile, hopefully pretty quick.
Hello.
Awesome. Oh, yeah, are we on time? Okay. Isn't it 30 minutes?
5 minutes.
Oh, 5 minutes. Gotcha. Awesome. I'm going to try and speed run this. But yeah, you can see here if you run the same command in this repo, we can see for the ABA contract on chain B, when we call this data field, and let's just pull up that test so we can make sure that I'm not lying. We can see here in test ABA that the assertion is basically checking for the chain B data, that it says chain A says hello. And we can see that it's asserting for chain A sender that it says chain B says goodbye. So we know that their messages were received on destination and acknowledged. I don't think I have time to go through the other 2, unfortunately, but if you want, please come by the booth. I will show you myself. One of them is batch sending, so being able to, in one send call, essentially do a for loop that sends to multiple different destination chains if you wanted to mass update data on other chains for one call. And the other call or other contract that we have is a simple composed example that shows you basically how after I receive some tokens from my OFT transfer, I could have a external function call here which executes after the receive logic. But I think for now, I'm just going to pause and open up the questions. Threw a lot at you guys. Thank you guys for the patience. Cool. Any questions? Let's speed run them. Yeah.
Is it propagated already, the first test you did?
Yes. Which test? This one?
The first message.
Oh, yeah. Let's take a look. Yep. Delivered. So we can go on destination, check here. And the way to check and make sure it's delivered, you can check the decoded input data, see that this is the source endpoint ID it came from, what nonce it is, the message, and then in the logs here, we care about the actual value being transferred. You can see a OFT received event emitted here with amount received. Yes?
For the presentation, is it possible to transfer native token like in here, directly with the ETHGlobal?
So there's a way to transfer native tokens. You can see in this gas setting here, within this call, this LZ received gas, this is 65,000 Wei of the native gas token on Sepolia, so ETH on Sepolia. We allow you, for the executor, to specify message value in gas in the native gas token up to a native gas cap. So if you want to do large transfers of native gas, you're going to need something else, but this is how you would do it in the calls. Yeah. Any other questions or, yep?
What size would you use the OFT versus OAuth?
The difference?
Yeah, like.
So that's a good question. Exactly, yeah. So if we look at the OFT contract, if you go in the stack here and go into OFT core is an OAP. OAP is just a standard contract interface that brings in all of the basic configuration logic and things you might need in your interface.
So if you wanted, like I'm trying to do like a cross-chain swap, so I'd use like an OFT contract then because it's swappable.
Yep, exactly. You could do it for ERC20 tokens, or if you had a different token standard, you would just modify on top of OAP. Yeah. Cool. Yes.
Last one, is there a maximum gas limit when you transfer data or OFT?
On destination chain, there is a max gas limit. Yes, it varies per pathway, but you can read it on chain. Yeah.
We can do complex operation, decorating contracts using layer 0.
Yes. Yeah. Cool. We can? Yes, you can. Yeah. And if you need more gas than what's provided by layer 0, you can use Stargate, which is a native bridge, and just use their interface to get even more native gas assets via the bridge itself.
But there is no cap set by layer 0
There's a cap set by layer 0 for the execution options. I can explain it a little bit more too. And then Stargate has no cap. It's whatever you pay for, you get. Yeah. Yeah. Cool. Yeah. Thanks, guys.
Yeah, some of this. Whoa, careful. Oops. Aw.
Yeah, anytime. Should we go? Okay, here we go. Thanks for showing up. I'm Austin Griffith. I am supported by the EF. I run a guild called Build Guild, and we're focused on developer education and onboarding. Particularly, the thing I'm going to be talking about today is how to build an app quickly. We're at a hackathon. This is the place where you want to sit down and write an app quickly and not have to spend a lot of time. So I'm going to show you how to do that here in an hour or so. Do we have one hour? Is that what do we have 1 hour? Okay, here we go. Okay, so Scaffold ETH has a lot of the stuff out of the box, and it's kind of the quickest time. It's like a hello world for Ethereum, but then you can ship it to production. It's like a hackathon stack that you can ship to production. It has all these components in it. It's good for tinkering. It's easier if I just get in and show you, though. So I'm going to go to Scaffold ETH.io. If you just search for Scaffold ETH, you'll find it. And I'm just going to follow these commands. Let's see. Let's go Brus. I'm going into Brus. All right, here we go. We're going to hopefully have decent internet. Oh man, maybe I shouldn't. I think we can do it. I think we're gonna do this live. I have like a backup folder just in case, but let's go for it. All right, and then we're gonna do a yarn install, and all of these commands are in the GitHub. I'm kind of going the long route here. Really, there's a really important moment, and we're not there yet, and I usually try to show that first, but I wanna start from zero, just to show you like how this works from scratch. So all we've done so far is clone down the repo. And then I'll CD into it and yarn install. We just did there. Okay, so it's probably really hard to see here, but this will be a yarn chain. And this is going to bring up a local blockchain. It either uses Hardhat or Foundry, depending on which one you select. If you want that choose your own adventure, you can use this command. We have a whole extension system, like a graph extension, where you just do, -E for the extension and then graph, and then all of a sudden you have all the graph stuff. But we're just going to use the vanilla Scaffold ETH here. I've got my chain up, then I'm going to yarn deploy, and that's going to throw an example contract to our local chain, and then I'll yarn start, and that's going to create our front end. So this is what it looks like when it spins up. You'll see probably around the venue a handful of Scaffold ETH variants, which is really cool. People have basically forked this and made Scaffold Op, Scaffold AA, Scaffold Nillion I saw, Scaffold Graph. There's just a lot of these out there, so keep an eye out for these. But the basic starter kit is this sort of like, you've got your wallet up here, you can go to the faucet, you can write a front end here, and we'll do that in a second, but the core piece is this right here. You've got this contract debugger. So this is like an automatic front end for your smart contract, and this is like the most powerful first piece. Definitely, like once you get out here and it's time to hack, there's gonna be this moment where you like need to tinker with your contracts and get the solidity right and kind of figure out how you want it to work. And that's what we'll do here in this first little session. So let's see. In the code, you'll have two packages, kind of your backend, either Hardhat or Foundry, and I say backend pretty loosely, right? That's your blockchain and orchestration. And then Next.js is your front end, your app. Let's get into the example contract. So Scaffold ETH starts with this example contract that has a bunch of stuff in it, but it tries to, just like the scaffolding around a building, right? If you need to work on a building, you're gonna build a bunch of scaffolding around it, do the work you need, and then kind of tear down the scaffolding. You'll probably tear most of this stuff out, but it's just good to have in your contract because it kind of shows you an example of how each one of these things work. For instance, primitive data types, events, the constructor, a modifier. It looks like we have a function here to set the greeting, and there's some interesting logic in this smart contract that we'll dink around with. And it looks like if there's money that gets sent into it, there's like a withdraw function that maybe only an owner could call to pull the money out. But what I want to show here is this interface where you have this contract debugger on the right, and then you have your smart contract over here that you tinker around with, right? And if I didn't have such a tiny screen, you can imagine that you can have these two things like side by side, and that's a way better experience. I'm gonna be like flipping back and forth between the two things. But let's say we create an address public Alice, and we just leave it blank, and I just hit save, right? Hey, it wanted to do Bob. Okay, let's do that too. Yeah, let's bring Bob into this mix. What's it gonna do? I kind of like, maybe the AI could just write my smart contract for me and we could, no, okay, it's just gonna do those two. That's pretty cool though. All right, here we go. Let's deploy this. Now what we're gonna see is, we're gonna see Alice and Bob pop up over here. There we go. So we have these new addresses now that we can see in the front end. And let's even maybe like set up like a function that, yeah, set Alice. That's what I wanna do. Let's go. And normally I would probably add like an only owner modifier on here or something, but we're just kind of like dogging out this code real quick just to show you as an example. Once you get out there and you're writing your smart contract, you'll be taking this much more seriously. Scaffold ETH does all the cool stuff around it, but this moment is a little silly for me because I'm just like making a fake smart contract, but you'll be able to focus on the logic of your app right at this moment. So don't take it too seriously, but don't take it too silly too. It's very powerful. So we have this Alice and Bob, and we have this new function now called set Alice. And if we wanted to set Alice to Vitalik.eth for some reason, I don't know why we would do that. Look how nice that is though, right? You get that ENS preview, you get the ENS avatar, you get the blocky. And then when I hit send here, I've already used my wallet. I've created a burner wallet and I've funded it. So watch this, when I hit send, I just made a transaction on my smart contract without a MetaMask pop-up, without it asking me to switch chain IDs and all that stuff. This is really nice. And we can see that Alice is updated to Vitalik, right? So we're able to tinker around with our smart contract, right? Let's say we wanted to count every time someone, whoa. We want to count every time someone updates, let's just call it the Alice counter. Man, this thing is good. It is like, maybe it's like hearing me. It like knows what I want to do here. And like I've never written this contract before either. Okay, so here we go. So now there's an Alice counter for some reason, and if I set Alice to ETHGlobal and hit send, we see that Alice counter increment, right? And if I click it a few more times, we see that counter increment. So this is the important moment where you're sitting down and you're writing your smart contract. And this is probably the hardest part of everything. It's like, how does this Solidity work? How do I make the contract do what I want it to do? What things do I store in the contract? What things do I store off-chain? What network am I even gonna use and all of that stuff? You'll spend a lot of time here where you're just kind of like trying things. And by the way, Solidity by example is really good. I like to tell people to have Solidity by example. When we were talking about having those two tabs, I like to have even Solidity by example in a third tab where I can be like, okay, so maybe I want to like bring in a mapping, or I want to learn what mappings are, right? I can read this, and I should, but I can also like drop that mapping in here and just go see what it does. So we just created something called my map, and it maps some address to some number, it looks like. And let's just go tinker with that and see what it does. So sure enough, we have this new read function called my map, and if I ask for any particular person's value, it's 0, right? So let's take my address actually, and let's give that character some, and let's not call it my map, that's kind of lame. Let's call it balances. It's balances, right? It's a balance. For an address, it's a number, right? It could be a counter or something. And then on the deploy, let's set balances, balances of that address to 1,000, right? And maybe we should do ether, right? Let's do 100 ether instead of doing 100, because that would be 100 way, right? And you guys all know that already because you're Solidity developers and you're about to crush a hackathon. You don't need me to tell you the difference between ETH and way. Okay, but let's see what we have here. So, wait, what did I just add? Okay, he should have deployed, he should have value, right? Let's check the balance of ETHG.eth. And hopefully it is 1,000 ETH, right? Okay, and then let's maybe even make like, so we're dinking around with a mapping, we realize we're saving balances. We're like, oh wow, we've almost made ourselves our own token. Let's like finish it off, let's make a token. So let's have like a send function or a transfer function, right? And that transfer function is going to do what? It's going to take in a to address and some amount. It's going to require that you have that amount. It's going to subtract it from you and add it to the other guy. If you're deep into Solidity, you know that we don't even actually need that, because at 8, you have overflow protection basically, and this won't work. But this require statement, while it costs a lot of money, it's nice to have that extra little feedback that says insufficient balance. Probably not something you would put on mainnet Ethereum, but maybe if you were on an L2, it might be worth that extra error. Okay, so we've set it up so I have a balance of 100 ETH at the start, and then I can transfer if I want. So let's try that. So now I'm going to connect my MetaMask address. And this is going to be a little weirder because we'll get the pop-ups and all of that stuff. Okay, but let's do that. Okay, so now I'm connected, and it'll force me over to switch the network. So anytime you're building an app, your users are going to come in with a wallet that's not on the right network, right? And so this is really nice because Scaffold ETH just forces your users to the right network. It forces this network switch, and it has all of this stuff built in. It's got a faucet, so I can click here and get some money. And then let's go ahead and transfer, right? Let's send Vitalik some. So to Vitalik, we're sending 69 of these things. Now, if I hit send right now, it's going to send 69 Wei. You have to hit this little button over here, and this is like a developer's interface. This is ugly and clunky, and I get that, but it's doing that on purpose. It's forcing you to have to hit this button to take it to Wei before you hit that button. And as a developer, you need to know that, but once we get in and start writing the front end, we'll do it automatically in the front end. So we won't have to do that math every time. You're just doing that as a developer so you learn. Okay, so let's see. Let's check Vitalik's balance now. There we go. So he's got 69 ETH of this magic token that we made up that's actually just a mapping of balances and a transfer function, right? Okay, so let's see. What kind of a smart contract are we really going to write? I probably want to do something where it looks like there's already an owner here. What do I want to do? I want to do something where maybe someone has to like input an address and save it. Let's see. There's an is owner here. I think I want to do like a set owner or like a force owner or something like that. Yeah, let's just make this contract ruggable. That sounds fun. All right, ruggable contract. Here we go. So you can definitely send money into this contract because it has this receive function. Okay? So I'm going to build like a trapdoor function here. Trapdoor. And what it's going to do is it's going to set we're going to let anybody call it address to, self-destruct too. I haven't seen that in a long time. All right, damn. Okay, we don't want to self-destruct. What we want to do is like send the whole balance, right? And if you, I always do this for sending Ether. I always just go to Solidity by example and search for sending Ether because the line is really, right here. Because you'll know that if you use .transfer or .send, those don't work very well with smart contract wallets. So what we need to do is this dog right here. Let's copy this. All right, so someone hits the trapdoor function. No, I don't want to send out all the money. We already have a withdraw function. See, this is the point. You're kind of tinkering. You're trying things. You're thinking through exactly what your smart contract should be. What I want to do is set the owner to this guy. Yeah, something like that. Let's just say rug. And it sets the owner to that. It's not letting me do that because, the owner is immutable. Okay, we got to make it mutable. Let's do that. Are we happy? All right, let's deploy it, see if it works, and then we're ready to go to the next phase. So let's say that you've spent the whole night tonight out here at the hackathon and you've been tinkering for a long time with your smart contract and you've got this part down. Like basically using the debug, you can make sure that if you wanted to, you could rug the contract to Vitalik or something like that. Let's make sure that works. And then we hit rug and we confirm. and Vitalik's the owner of the contract and could now take the money out. Okay, so our rug function works, I guess, if you want to call that working. It does the silly thing we want it to do, basically taking over the contract with anyone we send it to. Definitely don't want to put this thing on any like mainnet network because it just is a bad idea. You don't want any of this stuff here. Okay, and then like, ooh, beginning owner, we'll want to figure that out too. Let me delete the rest of this stuff though. Let's clean this contract up just so if I do put it on a network. Yeah, no greeting. There's a withdraw function. So like, yeah, so people can send money to the contract. The owner is set at start, and then anyone can change the owner. I kind of don't like that. It's a little weird. What if like only I can rug it or something? How about we do that? Just so I could put this out on a public network, because I kind of want to do that. So let's require at least that the message.sender is me. And we'll say not Austin for the error. Okay? So I'm making a very, very ruggable, weird contract. But again, pretend this is you coming up with the logic for your hackathon project, not making some weird ruggable thing. Withdraw is O. Yeah, okay, I'm not going to use even that modifier. I'm just going to require the message.sender equals owner. All right, are we happy? Can we please just move on? Yeah, no. In our deploy script, it's sending in a deployer for that address. Is that? No, it's this thing. Sorry. Get rid of this stuff. So in our deploy script, it's like going to check that greeting that we had. We had a greeting there. Let's see if that fixes it. Okay, finally. Okay, so let's pretend like we have our smart contract. It's ready to go. We basically have this contract that you can send money to, right? Let's send 1 ETH into it. Okay, so now the contract is holding, $3,000, and then we want to rug for some reason to Vitalik.eth, and we hit send there, and that should make, see, that's MetaMask takes forever to come up. That's why I like those burner wallets, but we're in MetaMask land for now. And then we make Vitalik the owner for some reason, and then Vitalik could get in here and hit this withdraw button, but I can't because I'm not the owner. Okay, you will make a more intricate and cool smart contract. But my contract is silly. It just is an example contract. Let's say you've gotten this far. You could technically just like put this out, right? We could deploy this and someone could get in here and kind of use this interface, but probably what you're gonna wanna do is build your own front end. So let's spend a little time there and build a little front end that lets someone come in here and rug the contract, okay? So our front end now, if we move over into front end land, we'll use Next.js. And if I get into the app page, here it is. This is this page, right? And it kind of shows welcome to Scaffold ETH2, and it shows who the connected user is. And then I think I want to delete everything else, and we'll put some nice UI in here in a little bit. But let me just kind of clean stuff up here. Let's see. Are we happy? Oh, that looks nice. Okay, and I'm going to say welcome to the rug store. Yeah. All right. Cool. And then maybe, let's see, what do we want to do? I kind of want to, well, I don't want to spend a ton of time making UI. What I want to do is just show, so first of all, this connected address is kind of interesting. If I go here, right now it's using an address component. Let's get rid of that for a second and just show what this would look like without that component. Okay, so we're using WAGME to get the connected address, and we're displaying it here. And let me save that. So here's what it looks like, right? Very ugly, giant string of hex. What you want to do is pass that into an address component. And that address component comes out of the box with Scaffold ETH, along with a handful of other components that are like bare essentials. And then if there's like a weird component you want, like a swap component or an NFT marketplace, you'll have to look to like the extension system, because not everybody wants that in their base code. So we have a very clean base here, and then you can grab other components from the extension system. But the key ones, you're always gonna use addresses. And you'll notice if I click this, this is gonna take me to whatever block explorer I'm on, right? So this is just a local block explorer. But as soon as we deploy this thing to a public network, and then all of my addresses throughout my whole app will now link to that public network's block explorer. And we'll get to that in a second, but let's make a little UI. Let's make a rug UI. So let's see, we want to know the owner. Let's display the owner, and then let's set up an input form that lets anyone change the owner, right? So that's gonna have us, we're gonna read from the smart contract, we're gonna keep track of some state, and then we're gonna write to the smart contract. It's funny because sometimes you'll spend more time here than you do over in the Solidity, and that's tough because the Solidity is obviously the hard part, but React is still a lot of work. So let's just make a read function first. So I'm gonna do use scaffold contract, use scaffold read contract, and that takes in, I think, your contract like this. Ooh, maybe it doesn't. It's been a while since I built on this. Use scaffold read contract, what does it take? Oh. It takes, okay. So I think maybe I do this, and I do contract name. Yeah, here we go. The rug store, is that really my contract? I don't think it is. It should autocomplete. Let's see. Let me get this set up. There we go. Now, this should, there we go, contract name equals, and I don't want to use, there we go, that's the important part. So right there it's saying, I've already looked at your contracts, I know the name of your contract, I'm gonna help you autofill it in there so you know you've got it right? And then I'm gonna hit control space again, and I'm gonna get function name, and then there we go. That's the only function name on the smart contract, but if we had a bunch of function names, they would show up here. And this is really nice, because you're like in here in the React writing your front end, but it already knows about everything about your smart contract, and it's helping you kind of guide you how to put these things in. Okay, and then, yeah, what's up?
Do you have, for that, the contracts under the contract directory in the Next.js?
The contracts, it's coming from the hard hat, and every time you compile from hard hat, it injects them into the Next.js in this folder called contracts. But if you have external contracts, you can plug them in too. So like if you wanted to fork mainnet and then talk to die, you could do something like that. Does that make sense? So it's both your local contracts and whatever contracts you want to define in this external contracts together. Cool? Okay, so then I got some data, and we're going to call that the owner. Okay, that was a lot of work just to read the owner from our smart contract, but now we have it. And let's kind of copy this code here and put this in here and put owner. All right, let's see, how are we looking? Yeah, there we go. Okay, so we know that I'm connected as me, and the owner is Vitalik, and we're able to read that from the smart contract. So then we'll want to give them some more UI to update the owner. So we'll say update owner here, and then I'm gonna have an address input component. Okay, and then let's see, if I go down here and hit control space, there we go. So we want, do I want a placeholder? Do I want a name? Do I want a value? What do I want? I definitely, let's see. We'll have a value, and it will be some local state variable, right? We'll say new address or something like that. And then we'll have an on change that maybe sets the new address. I think this is just V and V. Let's see what happens there. Anything else? Okay, so those elements aren't tracked in my state yet, but hopefully ChatGPT figures that out and just gives me this line. It did. Thank you, ChatGPT. Oh, and we don't have use state, so we need to import that. All right, now we should actually have, there we go. So we have an input field, And if I type something into it, it gives me all that nice stuff that we saw before. So this is another one of those components that comes out of the box with Scaffold ETH that helps you build your app quickly and have it look pretty good. So we're tracking it. We have this new address now in our state. So now what we need is like a button, right? And we want to be able to hit the button and save it, right? We want to send it. Wow, even gave me a little icon. Jeez, okay, let's see. Why is it not happy with that? Oh, slash button at the end, right? We need one of these. Okay, so now we've got, let's see. Yeah, we've got a button that lets us update the owner, and has a bug. Okay, cool. I don't know why. We have a little bug icon next to it. Okay, maybe we should actually say rug owner. I kind of like that more. Okay, and then what happens when we push this button, right? So we've done this, we've used this hook to read from our smart contract. Let's set up another hook to write to our smart contract. And it's gonna be a very similar naming scheme. Something will come back from use scaffold. Ooh, I wanna make sure I get this right. Use scaffold, write contract. And in this case, you just put in the contract name. That's why I was confused earlier. And then what comes back is this like async function, I think, yeah. Write contract async, and we'll call that write your contract. Okay, then we bring that down to our button, and right here we do write your contract dot something, I think. Oh, maybe it's a function? Ooh, maybe it's a function that takes an object. Yep, that's it. So we'll do function name equals, let's see, does it know? Oh, it knows. Look, there's a function called rug. That's great. And it knows that from our smart contract. So we will call the rug function with the args of new address. Is that looking good? Let's see if this works. I give it like a 40% chance of working. Let's see what happens here. So we would want to set this, let's just set it to us, right? So Vitalik is the current owner. I want to hit update owner. Holy cow, I think it's going to work. Dope. Okay, so we've made our rug store contract. We've made a UI so that our users can, yeah, yes, please.
Can you open the code, please?
Open the which thing? Code?
So there's an external contract thing at the
Yeah.
left side. Yeah. So how we can read this contract from the just something read contract function? How we can read this?
Yeah, if you just put an external contract in here, you'll have to define what chain you want the contract on, and then the ABI of the contract. Then it's going to show up. Oh man, it's going to show up right here. There'll be a tab system for all your different contracts as soon as you have multiple contracts, and it'll show up like right here, and you'll click it, and then you'll get this thing for that. Is that what you mean?
From the bottom parts, can you come to that?
From the, say that again? From the.
We just wrote the bottom bit, right?
Okay. So not external contract. Let's go from the button right here.
How can write or reads the contract with that function?
Okay, yeah. So you would do a use scaffold. You do the same thing. Use scaffold contract read, and your contract name would be whatever the name of the contract is in that external contracts folder. And by the way, like all this stuff, you can go to Scaffold ETH and docs, or there's like a Telegram channel with like all the guys who create and maintain Scaffold ETH are just like in that Telegram channel all the time. So you drop in the Telegram channel, ask that question, and you'll get some good answers from some folks too. Yeah, and I bet we could find like external contracts in here somewhere. Where's the search, man? We should definitely have a search there. Okay, whatever. I'm gonna skip that for now. We can come back to it. But yeah, as you want to talk to external contracts, you would put them in that external contracts folder, and then they would show up in that tab for debugging, but also the use contract read and use contract writes. Okay, here we go. Let's see. So where is our app? How far along are we? We have this, we have the front end built, we have the smart contract built. So now it's probably time to deploy, right? Like, it's really awesome when you can send the judges or give the judges like a live app, like, hey, we've deployed our app live here. So if we can get that far today, that would be good. We only have like 20 or 30 minutes left, but we're almost done anyway, so it'll be pretty easy. Again, you spend a lot of time here. You spend a lot of time writing your Solidity and getting your smart contract solid and tinkering with it here and making sure it works. And obviously you probably should write like some more sophisticated tests against your smart contract. Like I tested like 2 things and the contract literally is called rug. So we know that it's like shitty and not like a very safe contract. But your contract, when you put it live, needs to be very safe. Spend a lot of time testing it, make sure it's good. I'm glazing over that just to show the functionality here, but I don't want to minimize the idea of testing. You want to test a lot, but I'm not doing any here. So we're going to now deploy this thing, basically. We're happy with the way the contract works. We're happy with the way let's see, what happens if we redeploy this real quick? Who's the deployer at start? Oh, there's a little thing. Notice it didn't redeploy there. Sometimes you need to do a reset. If you don't change anything about the contract, you need to do a -- reset to force a redeploy. Okay, cool. So that connected it. So the contract deploys to a new address, and there's an owner, and anyone should be able to set the owner. Let's try setting it to Vitalik this time. Let's just make sure this works one last time. And if we're happy, we'll go to production with it. Okay, yeah, I think I'm happy here. So obviously this would be way more complex. You would do something really cool with your smart contract. I'm leaving that up to you. You guys are the big brains here. I'm just showing you how to work through this. Let's pretend like we have a dope ass smart contract and a beautiful front end. Now, what are the next steps, right? We're still on hard hat and we're still deploying to our local network. What do we do to take this thing pro or take this thing live? So first, we probably need to pick a network. We kind of need to decide where we want to deploy this. I will probably just deploy it to base. It's very irresponsible to be deploying a contract called the rug store that lets anyone rug it to a live network. Don't do that in practice, please. But I'm going to do it here to pretend to show you how you could actually do this on a live network. So I can't just deploy on base with so we've been deploying with this like faucet address basically. This is the 0 address on the hard hat chain. So it's loaded up with a bunch of money and it's great for deploying locally. But when we kill this chain and we don't use hard hat anymore, we're going to need to create a deployer address, right? So I'm going to yarn generate. And this is, you just do this one time for each project. You have an isolated burner wallet that's meant to deploy your smart contracts. And then if I do a yarn account, I should be able to get, there we go. Okay, now I'm gonna fund that with just enough base to deploy one contract, right? I'm not copy pasting my private keys into this folder and I'm not copying pasting those around, right? There's an isolated address here that I'm gonna have just enough money in, and I would have to work very hard to accidentally commit this thing to GitHub. And there's actually like better practices coming out. Foundry lets you encrypt your deployer keys, and we're getting to that soon. This is kind of an old way of doing this, but this is like the safest way to do it the old way as we transition to the new way. So yeah, let's just send some real money to this account and see what happens. Let me grab, so I'm gonna use a Punk wallet built with Scaffold ETH1. I've got some money on base here. Let me scan this QR code. I'm gonna send $1. What do you guys think? $5, just in case. I don't wanna have to send money more than once. Sometimes I've deployed contracts on base that cost like 10 cents. Sometimes I've deployed contracts on base that cost like $10. It kind of depends on what's going on with the blob space fee mechanism for L2s. But we should be ready. Let's do a yarn deploy, just like we were doing the normal deployment. But now I'm gonna do -- network base. And if everything works right, it should put our shitty rug contract out on base at a live address that anyone could go rug it. Okay, there we go. So our contract is on base, but our front end is still pointed at hard hat. So we need to go to our scaffold config and point it at base and hit save. Okay, and that one change, remember when I was talking about how addresses link to whatever network we're on? Now when I click this, it's gonna take me to the base explorer. So all I had to do is change that one line right there, and your app will work on any EVM compatible network. So yarn deploy -- network, any network you want, and you deploy it, and then you change it right in that scaffold config to whatever network you want, and your app is now pointed to it. And let's see how this looks. I mean, pretty good. It looks like it's working. So there's some owner that has deployed this contract. That's probably my deployer account, isn't it? Let me see that real quick. What's my deployer account? DBE? Yeah. Okay, so this is like that, the mnemonic that's there in my deployer account. They're the current owner. And let's send some money to this. It's so dumb. I'm gonna put $1 in this ruggable contract, and I don't know if it's gonna get rugged or if we'll have the time to rug it ourselves. But I wanna load it up and have it there just in case. Let's see, so copy this dude's address. Copying from MacBook. Yeah, what a cool feature. Paste. Oh, dog. Pasting from MacBook. It's like waiting. Okay, there we go. All right, I'm gonna send in $5. $5 ruggable dollars. Any of you can go get on Basecamp right now and rug this thing. Please don't. I mean, if someone's watching the network, they should be able to see it. But there we go. So there is $5 in this contract, and anyone in the world can put in any of their addresses and then come back over here and hit withdraw and pull that money out. It's kind of surprising that it's not already gone, right? Okay, so now let's put, the last little piece here is we need to put this app live, so then you can give the judges your Vercel, or you can give this to your friends, right? So we've put the smart contract live, but our app is still on localhost. So we have to do yarn, this is my favorite command, yarn Vercel basically deploys your app, but we want to yarn Vercel YOLO -- prod, I think is what it is. Let's see if that works. Yeah, I think it's working. Oh no. Vercel login, I haven't done that on this machine yet. This could be like very doxy. Let's see what happens. Oh, maybe I need to yarn Vercel login. I have no idea. Yeah, let's do it. This was not part of the demo. not supposed to be part of the demo. Oh, did it just work? Okay, yes. Sure. Yes. I don't know what's happening. Oh, okay, I think it's deploying. Okay, so when that gets done, should have a live Vercel URL that points to our smart contract that's deployed to base, and you could show that to the judges. And I did that in like 40 minutes probably, right? So obviously you'll spend a lot more time writing your Solidity, you'll spend a lot more time writing that React and getting it look good, but what you won't do is spend a bunch of time getting the wallet stuff to work, getting the network stuff to work, getting your addresses to look nice. Like there's all this stuff that comes out of the box. I've done so many different hackathons for like the last 5 years, and this is the kind of thing you need so you can focus on the logic of your app rather than all of the headache of setting up your stack and getting it running. So let's go rug this contract probably, right? I mean, that's probably, I'd like to do it from the live URL, but this might take a little bit longer. And yeah, go ahead. Yes, please. The YOLO command. What about it?
Is this one the good one?
Okay. So yes. So this stuff basically says, don't look at any of the type safety stuff. Don't do type checks. What you used to do at home is just yarn Vercel. I added this stuff because I don't want
numbers. I just want to like force it out so it works. But it's safer if you just do yarn Vercel. Yeah, I should say that too. All these like guardrails I'm putting on this, like I'm doing all these dumb things with this really powerful tool. I should really make sure to say those guardrails as we go. Yeah. Any other questions? I think we have time to talk through stuff. If anybody has any, yeah, go ahead.
Could you maybe talk a little bit about the extension stuff?
Yes. So let's see. The scaffold ETH extension stuff is still like super low key, but let's see. Scaffold graph extension. I think Kevin Jones is doing a demo of this soon. Also, shoot, okay, there's another one I want to show off too. Where is it? It's not like we're purposefully, because we're still like changing some things. We haven't put the docs live yet, I don't think. So it's still not quite ready for me to probably show it off. But the way it works is you do npx create ETH. Let me see if I can just Google it. It's that, and you do -e, and I think graph or something like that. Let's see if anything comes up. No, it's coming very soon, and there will be documentation right here. You'll land on scaffold ETH 2, and you'll type in what kind of an extension you want, and it'll be like, okay, here's how you -e. And basically, it's something like, let me just try it. I don't think it'll work, but let's find out. I think it's -e graph.
Is that for the graph?
Yeah, that would bring in the graph. I don't know if this is gonna work though. So soon, like within the next couple weeks. So we're launching it internally right now, and we're getting some people to build things. It looks like that did something. No, it failed. Yep. Yeah, okay, so it's invalid extension. So I'll have to figure out what that is, and we'll have to do better discovery. But seriously, like 2 weeks. Come back to scaffoldeth.io in 2 weeks, and there will be something here about extensions, and then that extension system hopefully will blossom into a shitload of things. Like so many little things like 712 smart contract, or there's a scaffold AA now, but say you wanted to do some kind of account abstraction or something like that. You don't want to build that into every single scaffold ETH, but maybe you want it. So that'll be why the extension system is so powerful. So there's scaffold AA. There's one called scaffold op.
So these wouldn't be ready to use for this hackathon, would they?
What would you use for this hackathon?
Or like
You could use the graph one. Yeah, Kevin can show you that. Yeah, I just don't know the actual. Do you know who Kevin Jones is? Here, let me show him. Shutterblock, I think is his name. Crypto Mastery, this guy. He's here. He will be having a beer with me in like 10 minutes right out here if you want to find him. Wait, I bet he even shows this off somewhere. Hold on. Let me see if I can find it. I feel like it's enough of a thing that I just want to answer this question, but I don't know what the, dang it.
You did the workshop. What do you need? What's the command?
Yeah. Is it it's -e something. Subgraph. Okay, let's try it again. So where was I? Was that? No, that's something else.
npx create scaffold ETH
-e subgraph. All right, let's do it. So you'll go to scaffold ETH, you'll grab that, oops. I like how we're delaying the rugging of that $5 and it's just sitting in there in the contract.
Yeah, I tried.
Okay. You've already tried to get to it? Nice.
I would have need to find out.
You've already would have rugged it? Okay, here we go. Scaffold -e subgraph. There we go. That's going to do it. Cool. And we'll have a lot more extensions soon. Yeah, for sure.
So, like, let's say, like I've used scaffolding before to do when I'm integrating like other projects or other packages from the product. What's the best way of doing that in scaffolding without like messing up?
Well, so as we build this extension system, we're also going to show people how to build their extensions too. So there's like an old way of doing it and a new way of doing it, and then we're right in the middle, and I only know about the old way, so it's better for me to like not explain it. Like I would say what you want to do is just wait for this extension system. Okay, so for this hackathon, you should just carve things out and just like just throw them in there.
for the next hackathon, keep an eye on our extension system, and that'll be the way to go. Has anybody actually rugged me yet? I feel like there's enough people in here that.
Put an error in there.
Let's see what happens. Okay, so I'm still the owner. My deployer is still the owner here. Let's see. So if you go to this address now, and I think actually I need to, like you said, there's like a gate on it right now. Like only I'm allowed to go to it. And I think what I need to do is like go to the settings and give everyone access. Let me see if I can find that. I don't see it though, right? You can get to it? Okay. Okay, so yeah, you can get to this next. You guys can get to this? Are you sure? Yeah. Let me go on my phone real quick. Have you already rugged it? I mean, like no one has rugged it yet.
You put in like last minute.
Oh, did I put in a thing that says only I can do it? Oh, never mind. Okay, that makes it way less cool. Okay, so right here, yes. Okay, well that's lame. Okay, well here we go. I'm gonna go rug the thing that only I can rug. That's way less cool. But this is really neat. Like the judges could just go to this URL, something that I've worked on for 40 minutes. It's a live smart contract app that uses all the state-of-the-art technology. They can connect their wallet, and they can update their owner to ATG.eth. And they could set that owner. Let's see if this works. I'm gonna actually pay money for this, right? But like a fraction of a cent. And then once that transaction goes through, like all my things are buzzing because transactions are happening. And then I should be able to hit this withdraw button. All right, are you ready? I have 48.68. And if I hit withdraw, hopefully I get my money back, which only me can get the money back at like nation state level security. Well, it's on base, so a little bit less hard than mainnet Ethereum. But yeah, that's kind of lame that I kind of set it to. Something didn't work though. Oh no, it's gone. It worked. There we go. The money's there. Okay. So I was able to make a smart contract that only I could rug, and then I can rug it. Way less cool. What you want to do is make a massive multiplayer smart contract, right? Your smart contract should be massive multiplayer out of the box. It should be more secure. You probably want to write some tests for it. You might want to spend some more time here making this look prettier. You definitely don't want a function called rug. You definitely don't want a function that says you have to be this person. Yeah, all of that. But hopefully this gives you an idea of how you can quickly get started building apps, and you can just kind of fork this thing and start building quickly. And it all starts at that scaffold ETH2 page. Any last questions? Awesome. Thank you all for coming. Yeah.